Okay, guys, so testing really is as simple as that. But before we go on to more complicated tests, I want to just make sure that we fully understand how this works. So we're going to create a few more dummy functions that we can use for testings. And if I go back to my calculations.py, I've already written this out, so I'm just going to paste it in here not to waste your time. But you'll see that they all essentially do the same exact thing. They just perform some sort of mathematical operation. So I've got the subtract function, which just subtracts two numbers. I've got the multiply, which adds two numbers. And I've got the divide, which just divides two numbers. So let's test this out now. The first thing that we got to do is, well, let's import all of those. So there's subtract, multiply, and divide. And let's define our function for subtracting. All right. And so just like before, I'm going to do a one-liner. So I'm just going to say assert, and we'll say subtract two numbers. What numbers do I want to subtract? How about 9 and 4? Whoops, 9 comma 4. And we know that 9 minus 4 should equal 5. So I can do assert equals 5. All right. And if I run this again, all right, we can see that both tests pass. And just to make sure that, our testing actually works, let's actually go into our code and let's essentially create a bug. So if I want to add two numbers, right, we know that's going to be num1 plus num2, but let's say, one of our moron colleagues went in and added 1, which is ultimately going to cause our function to break. And so ideally, if everything works fine in our testing, it should be able to catch this. Because if we add 5 plus 3, it's going to do 5 plus 3, and then it's going to add that extra 1. It's going to return 9. 9 equals 8 is going to assert to a false, which is going to throw an error. So if we try this out now, right, we can see that it did in fact fail. And because we set this to be verbose, we can see exactly what happened. So we ran the test add, and what happened was it asserted add 5 comma 3 equals 8. So it's asserting 9 equals 8, and that's going to throw an error. And so that way we see 1 failed, 1 passed, so the subtract function still passed because we didn't touch the code for that. So I'm going to go back and fix our bug in this case. And we're going to just set up a couple more test functions for multiply and divide. And I can just really just copy these actually. And I'll just change this to multiply, divide, and we'll just select a couple of numbers. So let's say, and I realized, looks like that's a typo. This should be multiply with an L. All right, and we'll say 4 and 3. So when we multiply 4 times 3, that should equal 12. And for divide, we'll change the function that we're calling to be divide, and we'll do 25. So 20 divided by 5 should equal 4. And so now if I save everything, we should ideally see all 4 of our tests pass. So let's try this out again. And you don't have to use the -v or the -s flag. If you're not printing anything or you don't want to see it, you don't need the -s. And maybe you don't want the verbosity, so you could technically remove those as well. And we can see that we get 4 dots, which means all 4 of our test functions have succeeded. If you're like me, the first thing that you may have noticed is that, testing with one set of numbers doesn't seem ultra reliable, right? That doesn't necessarily assure us that the function that we wrote actually does what it's supposed to do. I would ideally like to test with a couple of different sets of numbers. And the way to do that is, well, I'm sure if you just took a guess, right, you're probably thinking, well, maybe we just copy this function, paste it. Well, that should be back here. And then maybe just call this test add 2. Maybe we don't need this print statement anymore. And then you provide the other sets of numbers. So maybe like 4 and 2 should equal 6. And then you try this out and you run this. And we can see that that worked. And technically you can do that, but PyTest provides us a simpler way of doing this. So I'm going to delete this because we don't need that. I'm going to show you how we can do this using something called parameterize. So I'm going to import PyTest. So I'll say from, actually I'll just say import PyTest. And we're going to add a special decorator from the PyTest library. So we say at pytest.mark dot parameterize. And so here we can essentially provide a list of numbers that we want to use for testing and then provide what is the expected result. And so, our function takes two inputs, 5 and 3, and we also need to provide what is the result. So these are all the values that we're providing. We have 3 values for this specific function. So we're going to tell this specific decorator what are the 3 things that we want to provide for each test case. So in quotations, we'll do num1, num2, and then the expected value. Now, what you call these doesn't matter. It's up to you, right? But these are going to be treated like variables, essentially. So you can call them whatever you want. You can call this x, you can call this y, you could call this result. It doesn't really matter. But I'm going to stick with num1, num2, and expected. And more importantly, take a look at how this is set up, right? Your instinct is probably to do the end quote here, and then quote here, and then quote here like that. That's not what we want. That is not how it actually works, which I don't know why they decided to do it like this, but that's just what they've chosen. So instead, you remove these, and everything should just be one big string. So that's the first argument into this decorator. The second thing is going to be a list. And it's going to be a list of tuples, and each tuple should represent one specific test case. So the first tuple, we're going to provide our test case values. So we want, what is the value of num1? So in the first test, let's say we want 3 for num1. What's the second one? That's going to be num2. So it's going to line up with what we've put here. So we'll say 3, 2. And then what is going to be the expected value? Well, 3 plus 2 should equal 5. So we just say 5. And so that's our first test. If we want to add a second test, just do comma, add another tuple. And let's just add another set of numbers. So let's say num1 is 7, num2 is 1. We know that should equal 8. And just one more test. And here I'll say 12 and 4 should give us 16. All right. And so now what we can do is we can pass these variable names into our test underscore add function. So I'll say num1, num2, and expected. All right, so you want to make sure these match up with what you've placed here, because if this was called x, then you want to make sure that this is called x. But we'll change that back. And now in our code, we want to replace all of our test values with these variables. So this is going to be num1, this is going to be num2, and this is going to be expected. And so now if I run this, and we'll just do a -v just to see more in detail what's happening. Take a look at what's happening now. We can see that test add ran, and it ran with 325, which is the first test case. It passed. Then it ran the same exact test with these values, 718. That passed. And then it ran with these values, and that ran, and it passed just fine. And then finally, all of the other functions also passed as well. So this is one way of running the same test over with multiple values without having to just define 3, 4, 5 functions and just copying and pasting. It's a little bit cleaner doing it like this. So till now, we've just tested some simple functions, and you'll see that when it comes to testing, anytime you want to test a function, it's actually pretty easy. However, when you're working with classes, it gets a little bit trickier, and it usually involves having to write a little bit more code. So I've created a simple dummy class in this case called bank account, and this represents a person's bank account. And I've already written this out because I didn't want to waste your time writing this out. So if you want to pause this video and just copy down the code so you can follow along, go ahead and do that. But let me just quickly walk you through what this specific class is doing. But like I said, this represents a bank account. So first of all, we've got the constructor. So when we create a bank account, we can create a bank account with a specific amount of money, which is going to be referenced by the starting balance value. And then it's just going to set the balance property of the bank account class to be whatever you provide. If you don't provide a starting value, it's going to default to a value of 0. Then we've got 3 different methods. We've got deposit, which means we're going to deposit money into our bank account. So all we're doing is we're going to pass in a value, and then we're just going to add it to our total balance. Withdraw is the opposite. We're going to subtract a certain amount from our balance. And then collect interest is simple. We're just collecting interest. So here we just take our balance and then multiply it by 1.1, which I guess would represent a 1% interest rate. And so those are the 3 or 4 functions, methods, if you want to count the constructor method as well, that our bank account class has. So I want to go ahead and test this out now. So we'll go to our test calculations. And first of all, we want to import our bank account class. So let's create a test for our bank account. And the first thing I want to test is let's create a brand new bank account where we set the default value, to, the initial amount to be 50. So here I'll say test, and I'm just going to call this maybe test bank set initial amount. I want this to be as descriptive as possible. And so here, what we're going to do is, first of all, we're going to create a brand new bank account instance. And since this test is going to test to ensure that we have actually created a brand new bank account with a certain amount of money, I'm going to provide a value. Doesn't matter what value you decide to use, but I'm going to use 50. And we'll just store this in a variable called bank account. All right. And so to test if our function actually worked, or the functionality of our constructor method actually worked, what we're going to do is we just say assert, and we want to check the bank account dot balance property equals 50, because we set the default value to be 50. And if we just quickly go back to our code, you can see that we set the starting balance, or we set our balance property to be whatever the starting balance is. It just happens to be a default of 0 if we don't provide one, but we are providing one, and that's what we're testing. So we can test this. Let's run our code now, and let's see if this worked. We can see that it did in fact work. All right, and just to introduce a bug, maybe we set starting balance to be, -1, right? So we've broken our code. Now if we run this one more time, all right, you can see it failed because we subtracted 1, so we're asserting 49 equals 50, which throws an error, which means we ultimately fail the test. So let me remove that bug. All right, the next thing that we want to do is let's test to make sure that the default starting balance works as well. So I'm going to create another function, and I'll call this about test bank underscore default amount. So in this case, we're just going to create a brand new bank account, and we're not going to pass in a value, so it should default to 0 if our code works. And we'll store this in a variable just like we did before, and then we'll assert. I can copy this, but now it should equal 0. Okay, and let's test this out now. All right, and it looks like it worked, so great. And let's just quickly go ahead and test our last 2 functions out. Sorry, we got 3 more actually. So let's test the withdrawing functionality. So I'll do test underscore withdraw. And here we're going to initialize another bank account instance because we have to do that every time we want to test it. I'm going to give it a default value of 50. It doesn't have to be 50. Once again, you can choose whatever number you want. And we'll store that in a variable called bank account. And we'll call the bank account withdraw method. And we're going to withdraw, let's say $20. So we start out with 50, we withdraw 20. We know that the result should be 30. So if I just copy this assert statement once again, I can just change this to 30, and it should be no problem. Run this. Once again, all of our tests have passed. Let's try the deposit functionality now. So I'll create a test to test that. And I'm actually just going to copy all of this code because it's pretty much identical. You'll see that testing can become a little repetitive. We'll start out with an initial value of 50. It doesn't really matter. We'll change the method to be deposit. Maybe we want to deposit $30. So 50 plus 30 should equal 80. We test this out. Looks like everything's working. And the last thing that we want to test is the collect interest method. So let's create a function for that. We'll do test underscore collect underscore interest. And once again, I'm going to copy this code and we'll just use it here. We're just going to change the method to interest or collect interest. Okay, so we start out with the value of 50. And so what should the interest be? Well, if I take a look at what my method actually does, it just takes the number, multiplies by 1.1. So that should give us 55, right? 1.1 times 50 should be 55. So I will say this should be 55. And let's see what happens. So if I run this, we can see that we did have one test failed, and I'm assuming it's going to be the last test, the one we just created. And we can see the test collect underscore interest failed. And the reason for that is that it looks like bank account dot balance returns a value of 55.00000001, which in Python is not the same thing as 55. So this isn't necessarily an issue with our code. It's just the way that we're comparing numbers in our test. So this is an issue with our test in this case because it's not accounting for some of the different rounding and the way that calculations occur within Python. So what we're going to do is we can just call the round method right here, and we can round it to 5 or 6 decimal places, depending on how accurate you want it to be. So it should now round it to this value, however many decimals is 5 or 6, and then convert it to an integer. So then we can compare these two because this is an integer, this is technically a float. So they're not going to be equal in that case. So now if I run this, we can see that it did successfully pass. So that's just something to keep in mind. That's why I added that little extra test case, just to make sure that, especially when it comes to those calculations, you got to make sure that you're comparing the right two numbers. If you look through all of the test cases for the bank account, you'll notice that there's some repetitive code. Right? For every single test case that we have for testing our bank account, you'll notice that we always have to initialize a bank account instance. Right? And you can see that right now, look at that. We are repeating our code across all of our tests. And when you get to more complex classes, more complex test case scenarios, right, you might have 50 tests for a single class. And we're, in this case, just repeating the same exact code for each one of them. And so when it comes to writing these tests, PyTest does provide us with some tools that we can use to minimize the amount of repetitive code. And one of those is called fixtures. And a fixture is a very simple concept. It's nothing more than a function that gets run before each one of your tests, or at least the specific test that you want. So we can create a function which does nothing more than initialize a bank account and then return it to our function that's about to run. So I'll show you how we can do that. Right, the first thing we have to do is let's create our fixture, and we can put it anywhere. I'm just going to put it here for now. But generally, you want to put it at the top of the file. Actually, I'll stick to the best practice. I'll say at pytest.fixture. And then here we create a name for our fixture. So I'll say this is going to give us or initialize us a bank account with a 0 initial value. So I'll call this 0 underscore bank account. Right, and so all we're going to do is we're just going to return an instance of bank account with an initial default value of 0. And then we'll create one more fixture. And this one is going to return a regular bank account with an initial value. And what value we want to give it, we get to decide. So I'll just say return bank account, and in this case, 50. All right. And so now what we can do is, for all of these tests, I don't need to initialize them here because I can have these guys reference the fixture. So to assign a fixture or have a fixture get called for a function, we just pass it in as an argument. So for test bank account set initial amount, we're going to reference the 0 underscore bank account fixture. So what exactly happens is when PyTest goes to run this test case, because it sees this as an argument into the function, it's going to, that should be a 0. Okay. But what it's going to do is it's going to call this function before it actually runs the test case. So it calls this function, and then whatever we return here, which is the bank account, gets passed into a variable called 0 bank account. And so now, instead of creating a bank account instance, I can remove this and I can reference this variable, which is 0 underscore bank account. So let's test this out. Let's see if that broke anything. if we run this, oh, sorry guys. Let me undo this. I didn't mean to use this function. This is going to be for the test bank account default amount. So we want to remove this one. My apologies. And we don't need that in this one. And then this will be 0 underscore bank account. So now all tests should pass. All right, so everything passes. But if you're still a little confused as to what exactly is happening behind the scenes or what is the order of operations, I'm going to add a few print statements. So I'm going to say testing my bank account. And then I'm going to put in a print statement inside my fixture as well, which is say creating empty bank account. And so now if we run this, I want you to take a look at the code. And I realize I have to pass in the -s flag to see the print statements. All right, so here we go. We're going to test bank set initial amount. Sorry, no, test bank default amount. And so you'll see that when we start this test, first things first is we create an empty bank account. That's that print statement for the fixture. So before the test even runs, we call the fixture because we've defined that here by saying, where is it? That it's going to be an argument into the default amount test case. Then after the fixtures run, which is just a function, we then run our actual test case, and then we get the print testing my bank account right after that. So once again, just to really drive home this point, a fixture is just a function that runs before a specific test case. That's all. But the great part is we can use this same fixture for all of our other tests. So let's go to the next test, which is setting an initial amount. And in this case, we have this fixture right here, which is the bank account one. And so I'm going to say this is going to go to bank account. So this will call the bank account fixture, and then we can remove this line. And we can just keep this here because it's referencing this variable now. And this should work now. So if we run this, once again, all tests pass. And I can just do this for all of them. So I can just call the bank account fixture. And I can just remove that line. Everything else can stay the same. And the same thing here as well. And finally, for the last one, we can do that. And so now you can see that we have saved ourselves a couple of lines of code for each function. And if I run this, you can see that all the tests pass. So at this point, you're probably thinking, this doesn't really look like it saved us a lot of code or a lot of, coding out. However, there's going to be certain things that you want to do that you want to initialize before every single test of your entire application. So maybe something like setting up a test database, right? You'd want that to be set up for each single test. Having to manually do that for each test case would become very cumbersome. And then the lines of codes that you're repeating start to become a serious problem. And that's really one of the best use cases for using fixtures is something like setting up a database or setting up, some sort of email service or something that you're going to use across a lot of your tests, and then having to initialize that manually for each test is going to require a lot of work. And so that's where fixtures really help save us some time. Okay, what I want to do is I want to create one more test. And this test is going to be a little bit different. I'm going to call this test about bank transaction maybe. And so this is going to test us both depositing money and withdrawing money in one test case so that we can have a couple of different actions on a bank account. And so just like we've done before, when it comes to setting up a fixture so that we can retrieve an instance of our bank account class, I'm going to do the same thing, but we're going to use the 0 bank account. So it starts out with no money. And then what we're going to do here is we're going to reference the 0 when we're going to start off by depositing money. And let's say I'll deposit $200. And then we can also then withdraw a certain amount of money. So now we're testing both in one specific test case, and I'll say I'll withdraw 100. And we know that we should ultimately be left with $100. So we'll do assert 0 bank account dot balance equals 100. So let's test this out. And let's see how this works. And that works as well. But what I wanted to do is, for this specific test case, I wanted to show you that we can use fixtures and parameterize so we can test multiple values like we did for this specific test case. So what I'm going to do is I'm going to copy this so that we don't have to type this all from scratch. And we're going to create a couple of different test scenarios for this specific function. And in this case, we're going to have a deposited, we're going to have a withdrew, and we can have the expected amount. And keep in mind, you're not limited to having 3 variables. You can put as many as you want. It just happens to work out that I only need 3 in this case. And then we can provide some test data. So how about the same one we have right now? We're going to deposit 200, withdraw 100, and we expect 100 in the end. We can do the same thing. How about deposit 50, withdraw 10, and we should end up with 40. And then we've got our high roller, which is sitting there with a whopping $1,200. And he withdrew, how about 200? And he's going to end up with $1,000 at the end. And so now we can pass deposited, withdrew, and expected. And now we can use deposited here, withdrew here, and then we know what the expected is going to be. So let's try this out. All right, and we can see all 3 test cases run, and in this case, all 3 test cases passed. So I just wanted to show you guys that you can use this with our fixture. So it's okay if you're using a fixture, you can still use the parameterize decorator in this case to test multiple scenarios. If we go back to our bank account class and you take a look at the withdraw method, you'll notice that right now we're not performing any check to make sure that the user has enough money. And that's not really how a bank account works, because if you have $100 and you withdraw 500, the bank's going to be like, we can't do that. So it just makes sense in our code to actually perform some sort of check. And so usually, something simple is we'll say, hey, if amount that you're trying to withdraw is greater than your balance, well, what are we going to do? Well, we're probably going to raise an exception. So I'll say raise, and we're just going to raise a standard Python exception, and we'll just say something, hey, insufficient funds in account. Right? However, if we do have enough money, then we will actually perform that operation. So this is all good. If we go to our test calculations, and we just add one more scenario in this case, but this time we deposit, let's say, only $10, and we try to withdraw, 50. Well, what is the expected scenario, the expected value? And it doesn't really matter what we put in, because this is ultimately going to break our code, because we're raising an exception. So if I try to run this, right, it's going to fail because we're raising an exception. And remember, anytime you throw an error, that's going to automatically make the test fail. So what do we do? Well, first of all, let's remove this test case, because for scenarios like this where you expect to receive an error, we need to create a different test case. So I'll call this, how about test insufficient funds? And let's say we start out with, instead of using the 0 bank account, whereas the, instead of using this bank account, we're going to use the 0 bank account, and then we'll just try to withdraw money. So that's an easy way of testing it. So we'll say 0 underscore bank account. So we'll have no money in our account. And we're going to withdraw some money. So we would do, actually, I'll just do a regular bank account. I don't know why I want 0. So we'll start out with $50, and we'll try to do a bank account dot withdraw, and we'll try to withdraw $200. So that should raise the exception. But how exactly in our test do we tell Python it's expected to receive an exception? Because right now, if we run this, once again, we're going to get the same exact error. Right? Failed. So what do? This is how you tell Python that you expect an exception. You do with, and then you call pytest. Remember, we imported pytest all the way at the top right here. So we'll do pytest dot raises, and then you provide the exception that you expect. So in this case, this is just a regular Python exception. So you can just say that, and then you provide the command that you're going to run. Okay, and so that way, if this command throws an error or raises an exception, pytest will be told to expect this. So then it would consider the test as passing. So now if I run this, we can see that the insufficient funds test passed. And if we go back to our code and actually remove this exception, we'll comment out that entire statement. What do you think is going to happen here? Right now it's failed because it did not raise an exception. PyTest is expecting an exception and we didn't raise one. So then it considers that a error in our code, because when we expect an exception, we should expect an exception. So I'll uncomment this. And now, in real code, right, you wouldn't just throw just a generic Python exception. You're going to usually create your own exception classes. So let's say we define our own exception, and I'll call this insufficient funds. And this is going to extend the exception class. And we'll just say there's no properties. So I'll just say pass. And in this case, I'll say we'll raise an insufficient fund. Insufficient funds. All right, so if I make this change, what do you think is going to happen? Do you think it's going to break our code? Well, let's run this. We can see that it passed. And the reason why it passed is because insufficient funds is a child class to the exception class. So when we say we expect an exception, technically we are getting the exception. It's just we haven't specified we specifically want a insufficient funds exception. And because this is inheriting from this class, Python says, hey, look, everything looks good. But if you did want to be as specific as possible, which is generally recommended, what we can do is I can import that exception. So we'll say from app.calculations, we can import insufficient funds. And now here we can say we expect a insufficient funds. And so now if I run this, we can see that it passes. And the benefit of this is that if for some reason our code raised another type of exception, it would consider this test as failing. So if I go back to my code and let's say that, for some reason something broke in our code and all of a sudden, instead of raising an insufficient funds error, we get some other kind of exception. And I can just simulate this by doing raise zero division error. So if you ever try to divide a number by zero, this is the exception that's expected. And so now if I run this, right, we can see that the test failed because we expected a insufficient funds exception, but we got a zero division error. And so that considers the test as failing because we've told it we've expected something, but we got something else. So it's generally best to explicitly define the exact exception that you expect so that you can make sure that, that nothing else is broken, because technically any part of your code can break and throw an error. And if it throws an error and we just try to, if we just tell, our test to expect any exception, then it may not be doing what we actually expect it to do. But we'll change this back. We don't need that anymore. Okay, so I think we have a good enough understanding on how to create a test, and I think it's time we actually started testing our application. When it comes to Fast API automatically provides us a test client. So all we have to do is we just say from fastapi.testClient, import test client. And then all we have to do is then just pass in our Fast API instance, which is stored under the variable app, and then we can just perform any requests to our application by doing client, which is what we named the test client, and then just doing a .get or a .post or whatever, and then we can get the response, and then we can assert anything that we want just to make sure that we get the responses that we ultimately expect. And keep in mind, when you make use of this test client, right, if you take a look at the documentation, it says that you use this the same way you would any requests object. So if you've ever used the request library from Python, right, this is the same exact object. So anything you could do with requests, you can do with the test client. So you can customize the request. You can change the HTTP method. You can add a body, a payload. You can add a authorization header. It's really just doing what Postman's doing for us, but we're going to do it through code instead of manually opening up Postman and then figuring out which request we want to send. We're just going to do it out in Python, so we can do it all in an automated fashion. But if you haven't worked with the request library, definitely take a look at this. Just take a look at how we generate requests. It's not too difficult, right? It's just request.get, or in our case, we're going to call it client, but it doesn't really matter. And then you provide the URL that you want to run this against. And then, you can add in other properties like an auth header or anything like that. So it's just about customizing your specific HTTP request. And so I'm going to create a new file, and I'm going to call this, how about test_users. This module represent tests for, creating users and getting user profiles information and things like that. And just like it shows in the Fast API documentation, let's just copy this line right here. And then what we want to do is we want to import from our app package, go to our main file. We want to import our Fast API instance. So we want to import this app right here so that we can actually test it. So I'll say from app.main import app. All right, so we have our app instance, and we'll just copy this line right here, which is just setting our test client to a variable called client. And so now we can run whatever tests that we want. And I think, just to keep things simple, let's start off with the simple root path that we have right here, just to test that this works, because that way we don't have to worry about authentication or passing any other data. Let's start off with the simplest scenarios. So this is at the root URL. So we will go to our test users. And I'm just going to call this test root, because it's not really a real function or anything like that. And then here we'll say client dot. And since we are testing a specific path operation, this is a get method. So we want to send a get. So we'll do client.get. Then the URL. So we could just say /. We don't have to do localhost, because it's not technically a running server. We actually just pass the actual app instance. So we just say the root path. And then you can pass in other things like, what payload and things like that. But we'll leave that for now. Leave it empty. And we'll store the response under a variable called res. And instead of doing an assert or anything like that, for now, I just want to print out the response. All right. And if I run this, okay, so a little bit annoying thing. Right now, it's going to run all of our tests. And if you just want to test one test or one module, then I recommend you just do the same thing, except pass in the path to just your specific module, so that we don't run all of our tests all over again. So we can just run one in this case. And if we take a look at this, we can see that it just prints out a response object. Not very helpful. But if you want to see what's the actual payload, we can say .json to see what the data looks like. And so then I can run this, and we can see that, hey, look, we get message hello world. And if I wanted to grab the message property, I could say .get and then message, and it should return hello world. Let's try this out one more time. And we can see that it prints out hello world. So to test that this route actually works, what we can do is we can just do an assert. And I could say assert and then literally just copy this exact message And I can say, hey, the message should return a value of hello world. It's as simple as that, right? It's no different than what we did before with our, our addition function, right? We're just performing some action, running our code, and then making sure that the results are what we expect them to be. Right? And so now if I run this again, right, once again, still passes because it does return a value of hello world for the message property. And we can assert multiple things, right? It's not just one. We can do a second test case, and I can say res dot, and we can access a property called status code. It's even recommending that. So we can say, get me the status code. And I could say, well, I expect this to be a, if we don't change what the default status code is, it's going to default to a value of 200 as per the Fast API documentation. So this should be a 200. We shouldn't get any other values. So if I run this, once again, everything works. But if I go into my code and create a little bug, let's say I just add, an exclamation point or something. Then if I run this, we can see that it fails. And that's because we expected hello world, but we got hello world exclamation. So let's change that back. And this time, let's create a different bug. Let's actually change what is the status code. And so I can't exactly remember how to do that. So let's go to our post router. And we just set the status code right here like this. So if I copy this and go back to here, and actually, was it in the decorator? Yeah, it's in the decorator. You put that in there. And we have to import status. And so now if I try this out and run this, once again, it's going to fail. And that's because we're asserting, and the response was a 201, but we expected a 200 as per our test, which over here says it should be 200, and it throws an error. So you can see we could test a lot of different things. You can choose to test each and every property that you're interested in to make sure that the response is exactly what you expect it to be. But at this point, I think we understand how to send requests. So let me just, first of all, undo those changes that I just made just to make sure I don't break anything else in my app. And we no longer need to import that. So remove that. We'll save everything and let's just run our test one more time just to make sure that everything's good. And it looks like everything passes. Before moving any further, I want to show you a couple of other flags that we can pass to the pytest command so that we can kind of tweak the behavior of our testing. And the first thing that I want to do is, if you take a look at the output, you can see that we get a whole bunch of warnings. And depending on how many packages and libraries that you have installed, you could potentially see a lot more warnings. And I actually hate looking at these things. So what I normally like to do is I usually like to pass in the dash. I think it's a disable warnings, I think. And so now if I run this, you can see that there's no more warnings and we just see the testing information. So I think that looks a lot cleaner. And then the other thing that I want to show you guys is till now, all of our testing, when we've broken a specific function or class, we've only had one test fail. And I want to show you what happens when you have multiple tests fail. So we go all the way to the top in the test calculations folder, and then maybe I just change, the subtract function. So I'll change this to be 6 so we know that it's going to error out. And then also at the bottom, I'm going to change this test right here so that it returns 56 instead of 55. And so if we run this, and I'm going to do -v so we can see verbose, but you don't have to do that. But if you take a look at what happens, you can see that, it runs the first 3 tests, and then the 4th test fails, and then it just continues running through all of the other tests, and then it fails on the next one, and then it finishes running all of the other tests. So the default behavior is when a test fails, we're going to continue running all of the other tests. And this may not be the behavior you want, so maybe you've changed your code and you just want to see if we've broken anything. And so you want your code to ideally, run through the test, and the first time it fails, you want it to stop so that you can, then fix that issue and then run through the rest of the tests afterwards. Or you can manually run it again because, right now we only have like 16, 17 tests. So it doesn't take that long. But when you start to write a lot more tests and your code starts to grow, these tests can take, minutes, sometimes more than that, depending on, are you using an external API? Are you using a database? These all add a significant amount of time for your tests. And so if you just want to see if you've broken anything, you may want PyTest to stop on the first failure. So if you ever want PyTest to do that, all you have to do is you have to pass in the dash X flag. So this will tell PyTest to stop after the first test fails. So if I run this, you can see that we get pass, 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 and then the first test failed, and then we stop and we don't do anything else. And so those are just the 2 flags that I wanted to go over. I don't think we'll really cover any other specific flags. I just wanted to go over these 2 because they just happen to be 2 of the ones that I do like to use occasionally. But let's make sure we go ahead and change all of our code back. So I think we changed this one. This should be back to 5. And this should be changed back to 55. And just to make sure, let's just run our code once more, just to make sure we didn't break anything, and we could see all 16 tests pass. So now that we know how to simulate a request to our API, let's create a test for testing the user create functionality. So what we're doing is we're going to create a user, and we're going to test this specific route right here where we create a user. So let's try this out. We're going to do the same thing. I'll call this def test underscore create underscore user. And here I can say res equals client like we did before, but this time it's going to be a post request. And the URL that's going to be /users. All right. And then since we're now sending a request, to create a user, we have to send data in the body. So to send data in the body, you say JSON equals, and then you pass in a Python dictionary. So this is going to get sent as the body. And if you go back to our specific route, which is right here, you can see that we expect the users create schema. So if we take a look at the schemas, you could see that somewhere in here, where's user create? Here we go. We expect an email and a password. So let's send an email and a password. And so for email, we'll say this is going to be hello123@gmail.com. And the password is going to be password123. And just to see that it worked, let's do a print, and I'll say res.json. And then the test requirements, how do we verify that it works? Well, let's start off with something very simple. So we'll say assert, and I'll say res.statuscode. We know that when we create a user, we expect a 201, and we can just verify that by taking a look at the path operation. But I think this should be good. And then now if I run this, and I'm going to run just this file. So I'll say test user. And let's see what happens. So we see both of them passed. And how do we verify that? Well, we should see this user in our database, right? So if I go to my PG admin, go to my database, and we'll go to our schemas, tables, and go to users, and we'll do a view edit all. All right, we could see the hello123, so it was successfully created. I'm just going to quickly delete this again. Well, actually, let me show you what happens if we don't. I'm actually going to do something unique here. I'm going to say, well, actually, let's just do an assert, and I'll say res.json.get, and we want to get one field just to verify that it's correct. So what's the data going to look like when it comes back? Well, we should see a print, but I didn't. That's because I forgot to do the -s flag. But going back to the route, we're going to send the response as a user out. So we expect it to match this specific model right here. So it should have an ID, an email, and a created at. So let's add that in there. I expect the email to equal the email that I gave it. And you can really do as many, asserts as you want. So you could verify each single property has been set. You can verify that an ID has been set. I'm just going to keep it simple. We'll just say just the email. We'll just run that check. And so we'll run it again. And I'm going to do the -s flag as well. All right, and we see that it failed. And we can see that it failed because there's a duplicate key violates unique constraint of email. And that's because this user was already created, so I can't recreate him. So let me delete this. And I don't think if I select the number and then go to, oh no, it doesn't look like I can. There we go. Now once I select that number, I can delete this user. And then we could save that to database. And so now if I run this again, we should see it work. And we can see that both tests pass. And we can see that both of our assert statements were checked and validated, and they both looked good. But instead of doing it like this, we can even take it one step further. Instead, what we can do is I can actually import this user out schema into my test. So I can say from app.schemas import user out. And then I can remove this print statement. And what I can do is here, I can actually use the schemas. Actually, sorry. I'm actually going to change this import. I'm going to just import all schemas. So I'll say from app import schemas. And now I can actually create a new pydantic model, and I'll say schemas dot user out. So we're going to create a new schema, save this as a variable. I'll call this new user. And we can pass in the data that we get back from the response. So I can say res.json. And remember, we have to actually unpack the dictionary so it's in the right format to create a new user out model. And now this is going to perform a certain level of validation. So it's going to confirm, hey, do we have an ID? Do we have an email? Do we have what was the other thing that we needed? And do we have a created at? So it's going to make sure it's got these three things. It's not going to check to make sure that it's the right email. It's not going to check to see if it's the right ID, but it's going to check to make sure that at least it has these three properties. So it automatically does some of the validation for us, and it'll throw an error if one of those are missing. And if it throws an error, then obviously PyTest will consider this test a failure. So by doing this, we've kind of saved us a little time. And now I can actually change this. Instead of doing this, I could say new underscore user dot email equals this value. So now if I run this, hopefully this works. And it looks like it failed. And let's quickly see what happened here. Oh, once again, I forgot to delete the user beforehand. So we'll delete him and then try this test one more time. And they passed. So I think this is what we're going to do moving forward. We're going to make use of our pydantic models to do some of the validation for us automatically so that we don't have 60 or 7, probably not 60, but we won't have 5, 10 different assert statements, which you can absolutely do. And you probably do want to, but this will remove some of them because it's at least checking to see if some of them are there. So before moving any further, we need to address something important. And that is that right now we are using our development database for our tests. And that's not good. I don't want to use my development database. I want to create my own separate database to perform testing on so that I don't get in the way of development or staging or any of our production databases. I want to create a completely separate database for testing. Right now, when we import our client, right, we're going to be using whatever the database is that we've defined in the rest of our app, which is going to be our Fast API database within pgadmin. And we can see that right here. And so that's why I'm having to go in and make sure that it's created. And we've already got some other data which could potentially break our tests. And so I want to make sure that we have a completely separate database for testing so that it does not get in the way of anything else. So how exactly do we do that? Well, one of the great parts about the way we've set up our database is if we actually go to our database.py file, right, you could see that we've actually set up a dependency. So when we set up our dependency, you can see we created this function called getDB. And this getDB actually returns the session local. So this is what allows us to actually, make queries using SQL Alchemy. And that comes from this right here, from the session maker where we passed in all of our database connection details. And if we go into any one of our routes, it doesn't really matter which one, you can see that we pass in the dependency into the route. And the great part about having dependencies is that it's very easy to override a dependency in any environment, especially a testing environment. We can say, hey, instead of passing in, get DB, we can say, something like get, underscore test underscore DB, which is going to be a function that returns a test instance of our database instead of our development instance of our database. So I'm going to show you guys how we can set that up and how easy that is. So we'll go back to our test users. And we're essentially just going to copy all of this right here. So I want you to copy this all the way up to the URL. And we'll have to set up some imports, and we'll come back to that in a second. So let's just create some space. All right, so we've got all of this, and we need to import a few things. So we'll start off by, we'll have to import settings. So we'll say from app import. Actually, we'll say from app.config import, I think it's settings. Yep. All right, so we've got that cleared. We then have to import create engine. And so we'll go up here and I'll say from SQL Alchemy import create underscore engine. And then we need our session maker as well. And I think if I hover over this, nope, it doesn't look like it'll auto import that for me. So I'll say from SQL Alchemy.orm import session maker. All right, looks like we got most of the issues. We still need declarative base, and we'll import that. I'll say from SQL Alchemy.ext.declarative import declarative base. And if you guys don't know where I'm getting this, I'm literally just copying this straight from this file. So everything that's here, you can just copy it as well. And if we go down, I think we have everything, right? We no longer have any errors. So we've got all of our imports. And so this is the function that returns our session local. So this is what allows us to query the database. This is our session object, right? And this is how it's set up exactly in the database.py file. So what I'm going to do is I'm going to create another function, but this time I'm going to call it override underscore get underscore DB. And this is going to return this session local instance. But I'm going to rename this just so I don't get it confused. And I'll call this testing session local. And then I'll reference this. All right. And so that means right now in our current application, we're referencing the one that we created in our database.py file. But the one in our test, we're going to actually make use of this new one right here if we call this override get DB. So how exactly do we override the database or any dependency, really? Well, FastAPI has a section on here, and I think if I search for dependency, testing dependencies with overrides. All right. To actually set up the override, you just do app.dependency override, and then you provide what you want to override it with. And there's actually a better example. If I go to testing database, this will actually show you how to do that. So we've got the override DB, where we've created a different session object. And to override it, we just do app.dependency overrides. We pass in, we specify the dependency we want to override, which is anything with getDB, and then we want to override it with override underscore getDB. So essentially all that's really doing is in the functions, any of our routes, right, you can see we've got this depends getDB. So when we run that command right here, this override, all it's going to do is it's going to swap this out with the function that we have right here under test users called override getDB, which is just going to give a different session object. And this session object can point to another Postgres database. That's all we're doing. It's really that simple. That's why we set up that dependency when we first started configuring our database so that we can easily test this during testing because we can just use the override functionality that's used within a Fast API. So I'm going to copy this. And right here, I'm going to paste it down here. And I realize I misspelled override. But we do have to import getDB now. So let's import that. So I'll say from app.database import get underscore DB. And so it's going to swap the dependencies out. And since we're still referencing the app object, we're going to pass that into test client. And so now anytime we use this client, it's going to use the new database. Now, currently our database is using the environment variables, which once again is going to point to our development database. So there's a couple things we can do. Since this is testing, we 100% could just hard code our URL, because I mean, it's our testing database. Who cares if our password and our information is already out there? So we could technically do an F string. Actually, we don't even need an F string. I could just say PostgreSQL. Whoops, this should be a string. PostgreSQL : // then we have the username. Right now for my database, it's just Postgres. And then we have the password, which is password123. Remember, this would technically be for your testing database, so it's not technically a problem if you put this in there and hard code it. However, you'll see that we could just use the environment variables and make a small tweak, but I'm just going to quickly write this out for you guys if you wanted to see it. And then the host name is going to be localhost, port is going to be 5432, and then our database name. So we could call this, my development database is called Fast API. I could call my testing database maybe Fast API underscore test. So whatever my project name is and then underscore test, you can call it whatever you want. And so I could just hard code that and then comment this out, something like that. Or I could use this same thing, but just do a underscore test here. And so that way I don't have to hard code anything. And it's going to actually pull it from the environment variables. So whichever method works for you, ultimately, that's all that matters. Now, I technically already have a Fast API test database. So I'm going to actually delete this for now. So we'll say delete drop. All right. So I'm now in however your Postgres instance is set up. But since we're going to be using a database called Fast API underscore test, we actually have to create one. So I'll say create database and I'll say Fast API underscore test. Okay, so we've got our test database created. And we've set up the override. Let's now actually test this out. So we're going to do one last thing. And I realize since we have a brand new database, there's no tables, right? If I go down to schemas, tables, right? There's nothing there. So we actually have to build out our tables before we actually do anything. So easiest way to do that is just copy, where's my main file? Here we go, this command right here. So this will tell SQL Alchemy to build all the tables based off of the models. We could use Alembic as well. So I'll show you guys how we can kind of get Alembic set up in our testing database so that it actually performs the migrations before test. But for now, we're going to keep things simple and we're going to use this. And so I'll just paste it right there. And we can remove this models. I don't know why that's there. And you can see that we get a warning right here. So we don't have anything base. So we actually have to import that from our database file. So I'll say from app.database, import base. And I realize we actually don't need this line right here. So we'll remove that. All right. So now our test database is completely set up. And when we actually run our first test, it's going to run this right here, which should create all of our tables for us. So let's take a look at our test create user. Everything should be good. We shouldn't have to touch anything. And our URL should point to Fast API underscore test. So let's try this out. And I'm just going to refresh this. And yep, we shouldn't have any tables. Good, perfect. And let's run this now. So let's run just the test users. All right, and both of them passed. So how can we verify both of them passed? Well, let's go to our tables. I'm going to refresh this. We can now see we've got all three tables, right? And that's because we ran this specific, well, not that command, this command right here. And if I do a users and then where is it? View edit all data, all rows, right? We can see that our user was successfully created. So we have now gotten our test database set up so that we no longer interfere with our development database. And keep in mind, right, your test database doesn't even have to run on your local machine. You can run it anywhere. You can run it in a Docker container. You can run it on a remote machine. You pass in the details of your test database, and then your testing environment will handle the rest. So now that we've got our test database and we've successfully ran our tests, if we run our test one more time, take a look at what happens. We get an error, right? And we get an error because we saw this before in our development database. We already have a user, so we get this duplicate key violates unique constraint because this user already exists. So when we run this again, we try to create a new user with the same exact email. And this obviously causes things to break. And so how do we get around this limitation, right? I want to be able to run my tests as many times as possible, and I want it to kind of start out with a clean slate. Well, we can make use of fixtures. So let's take a look at our fixture. And if you already forgot what a fixture was, it's just a function that runs before your test runs. I'm going to create a fixture, and I'm going to have to, do we already import PyTest? We did not import PyTest, so let me import that in here. We'll say import PyTest. And I'm going to say, I'm going to create my fixture. Call this whatever you want. I'm going to call this client. So this is actually going to return, our client, right? This is our client object right here, which is the test client, which is what we use to actually generate the request. So I'm going to call this def client. And what this is going to do is I'm going to remove this line right here and just copy this. And I'm going to say return this. And we can just remove this line at that point. So this is going to return our test client instance. And so now to get this to actually work, I'm going to pass in our client. And so now this client object references the client that we get from this fixture. And we'll do the same thing here. So what exactly has this solved? Right now, it hasn't really done anything for us, right? Our code is going to work exactly the same. If I save things and run it again, right, same exact issue. And obviously I can go in and I can delete this and then run this, right? It's going to work just fine. But it is nice because we now have this function that runs before each one of these tests that gives us our testing client. And what's even better is I can actually change this a little bit because I can change this to be a yield. Right? When you change it to yield, what it does is it gives us a little bit more flexibility because now we can, run our code before we return our test client. And after the yield, we can then run our code. Actually, this should be run our code before we run our test. And then this is going to run our code after our test finishes. So now we can put in logic for, what should we run before our code runs or before our test runs. We then yield, which is the same thing as return. It's going to return our test client. And then we can run some code after the test finishes. So what we can do is, before our code runs, I can copy this line right here. So before our code runs, I can create my tables. And then after my code runs, I can drop my tables. And if you want to drop a table, you just run base.metadata.dropAll instead of createAll, and it's going to drop these tables. And so now every single time my tests run, I'm essentially going to be starting out with a clean slate. It's going to drop all of our tables, all the data in each table. It's going to return the test client. We're going to run the test. And then, I messed that up. So when we finish a test, we're going to drop all of our tables, delete our data. Then the next time the test runs, what's going to happen is we're going to create all the tables again because there's no tables. We're then going to run the test. And then just like we did before, we're going to then drop all of our tables again. So what I'm going to do is, first of all, I'm going to manually drop these. And I'm going to have to drop votes first, or then it's going to throw some foreign key errors. And then we'll drop posts and then users. Okay, so now everything should work. And I'm actually going to test this out. So once again, just to reiterate, we're going to create our tables because we don't have any. We're going to then run our test, right? Yield just returns our test client to our create user, and then we can, perform all of this logic. After that's done, we'll then drop the tables again so we start from scratch the next time around. So let's try this out. All right. Everything's worked. And if I actually go back to here and hit refresh tables, you can see there's no tables because we dropped the tables after we're done. And if I run this again, it works. We can run this as many times as we want. We don't have to worry about duplicate users because we're clearing out our database. And there's one more thing that you can do as well. If you wanted to, we could actually take this drop all and move it up here. So what's the benefit of doing like this, or why would you want to do it like this? Well, the nice part about this is, right, it's going to clear out anything we had previously. It's going to create our tables, and then it's going to run our test. And then the next test that we run, we're once again going to clear out our table. We're going to clear it out, and then we're going to build our new tables again. So this way, if your test fails, you can, pass in the dash, X flag to stop after it fails. And what's going to happen is it's going to keep all your tables and all of the data so you can see what was the current state of your database when the test failed. So that you can, ideally have a little bit of better idea of what's happening, troubleshoot a little bit more because you have access to your tables. Whereas if this is down here, right, it's just going to delete the tables after you're done and you can't even see it. So it's a matter of personal preference, but I like to keep the tables after it's done so that, if I do want to stop it and just kind of poke around and take a look, then I can. And if you guys don't want to use SQL Alchemy, you can do the same thing with Alembic, right? I can import, alembic.config. Actually, I think technically the import is from alembic.config import config. Sorry, not that. Nope. It's from alembic import command. So what we could theoretically do is in here, instead of using these, we could say something like, I think it's command.upgrade. So you can upgrade, and then you can go upgrade to, I think, head, right? So this will build out all the tables for you. And then after you're done, you could then go in and say command.downgrade to base or something, right? You'd have to make sure you set up Alembic with all of the right environment variables and things like that. But that's all you would have to do if you didn't want to use SQL Alchemy's built-in functionality. So I'm going to just delete that just to keep things simple. We're going to let SQL Alchemy build the tables for us moving forward, just because it's a little bit quicker than having to build all of your revisions and things like that. So one of the cool things with fixtures is that we can actually configure a fixture to be dependent on another fixture. So we can essentially pass one fixture into an argument of another fixture. And the reason why I want to do this is I want to have one fixture that returns my database object. So if I want to ever manipulate data directly, and I want another fixture that returns my client. So this one is returning our client, so I want that. But I also want another one that returns just our database object. So what I'm going to do is I'm actually going to create a new fixture. I'll say pytest.fixture. And we can call this whatever you want. You can call it, like DB or session. I'm just going to call it session. And I'm actually going to move the logic of deleting and creating our tables up to here, because this is kind of handling all of the logic for the database. And you see all of this override functionality. What I'm actually going to do is I'm going to just copy this section right here. And paste it into here. All right, so this session fixture is going to yield the database object. So the database object that we used to query things. And what I can do now is I can pass in this session fixture into my client fixture. And so by doing it like this, what's going to happen is any time I go to one of my tests and I pass in the client fixture essentially as a dependency, it's going to call this one. And the client fixture will actually call the session fixture before it runs. So it's intelligent to understand that a requirement for the client fixture is the session fixture. So we're going to run all this code. It's going to return the DB object, which is going to be passed into client as the session. And then here we can perform all the logic that we normally would. And I'm going to once again copy this override DB right here. And we can remove this. And we can remove that. Nope, actually, sorry, I didn't mean to remove that. Just space these out a little bit. So it's part of the override getDB function. And here, instead of yielding DB, since there's no DB, we're going to yield session, which is the DB. So we'll say session, and then session.close. And I'm going to copy this line right here, do the override right here, and then we return a brand new test client. Okay, and the benefit of this is that not only do we get access to the client, if we wanted to, we can also get access to the database as well. So I could say session, and then I can go in here and I can make queries like session.query, models.post blah, right? So now I have access to the database object as well. And so I can make queries and I have access to the client. But if I call just the client, remember, the session database is an input argument into the client fixture. So the session will always run first, and then client will run because we're calling it right here. And then we just move the override getDB function into here as well as the override right here. And then as usual, we return the test client. So let's make sure we didn't break anything. Let's test out our code. And something's happening with my terminal, so let me open a new one. So let's try this again. I'm just going to do pytest test / and then test _ users. Nope, not test calculations, users. All right, and 2 passed, so perfect. Looks like we didn't break anything, and we've got a much nicer way of setting up our code. We can actually remove this override that's not within a fixture. We no longer need that. And we no longer need the create all right here outside of any of the fixtures because we're doing it all within the fixtures now. And once again, I just want to make sure I didn't break anything, so let's test that out. And we can see 2 have passed. Perfect. All right, so right now our test users file is a little bit cluttered with all of this database information, and I would like to move all of our database specific code to another file. So under our test folder, I'm going to create a new file, and we can just call this database.py. And I'm going to essentially move all of my database code to that file. And that includes the fixtures as well. So these 2 fixtures, all of this, actually everything. We don't need any of this in our test users file. And we can just paste it into here. Now, this is going to break things because obviously it has no idea what schema. Okay, well, actually, before we do that, we do need to have schemas in here. So let me find where schemas is, and we'll just cut that out. But the other issue is that we no longer have access to the client fixture. So we have to import that. So I'll do from current directory database import. What is it? Client? I think it's client. Yep. So now we have client. And remember, we don't need to import. Actually, we may need to import session. Let's just double check to see if this causes any issues. So let me save everything. And let's test this out. Let's see if this works. Looks like we got 2 errors. Yep. And if you take a look at the errors, it says the session fixture is not found. So we actually have to import the session fixture from this file. Even though we don't actually call session in here, because client is dependent on session, because client is ultimately calling session, we need to make sure that session is also imported. So we have to do session here as well. And so now I think this should fix our issue. So now if we run this, yep, both tests have successfully passed. And if you actually take a look at our test file, you can see our test file is a lot cleaner. It's really just got our 2 tests and a couple of imports. And before we move on any further, there's one thing I want to point out, and I ran into this issue when I was, doing a dry run through my code. If you actually take a look at your routers, and we'll go to, since we're taking a look at test create user, this is going to be the /users. So we go to users and then create user, right? You can see that the prefix is /users. So the route you want to go to is /users, and then you can see that we have to append whatever's here. So here it's appending /. Now, the way that PyTest works is that, or actually the way that anything works is that if you actually send a request to /users, it's a little bit different than /users/. And I'm actually going to show you what happens when we do that. So I'm going to, first of all, open up UVcorn. So I've started out my API. And if we go to create user, here I'm going to users and not users/. right? I'm not doing slash, I'm doing slash user. I'm just doing users, which is, wait, where did it go? Is it here? Where did I put the things I just typed? Yeah, here. So what we're doing is we're sending a request to this one, not the one above it, because the other one above it has a slash at the end. We don't have that trailing slash. So if I create a test user without that trailing slash, hit send, take a look at what happens in the logs. It says that when we get a request to slash users, we're going to send a 307 redirect to slash user slash, because technically the route's on slash user slash, and Fast API is intelligent enough to actually send the redirect to here. However, this creates an issue with our testing, because if I just do slash, what's going to happen is when I do this res.status code check, it's going to check for 307 and not the final 207, the final 201. And I could show that to you guys. So let me go down here. We'll run our test real quick. And you'll see that it fails, and it fails because, well, there's a couple of issues. It fails. It says it fails because our validation for our schema failed, but I'm going to skip that and comment that out. And I'll comment this line out. I just want to take a look at the status code, because obviously if there's a redirect, there's no information in there. Right? And you can see that this fails because the response code is 307. So that's why you want to make sure you add that trailing slash, or then you'll run into some issues. So we've got our create user test pretty much done. You can feel free to customize it however you want. If you want to add a few extra assert statements, feel free to do that. But we're going to move on to login. So let's actually handle setting up the login. So I'm going to do def test underscore login underscore user. All right. And this test is going to be dependent on the client fixture, because we need to be able to send a request. So I'm going to pass in client. And I'm actually going to copy this line right here. We'll change it, of course, but all right. And so this is going to go to slash login. And there's no trailing slash on this one, just because if you actually look at our specific route for login, I think it's under auth.py. You can see there's no prefix here. It's just slash login. So we don't need the trailing slash on this one. You just have to figure out how you set yours up and make sure it matches accordingly. We do slash login. But in this case, we don't want to send this data in the body. Instead, remember, if you go to Postman and you go to login user, we don't send it in the, we do send it in the body, but instead of using the normal JSON format, we have to send it as form data, remember? And so to change this to be form data, you just change JSON to be data. And we've got the same credentials, so this should work. Let's just quickly just do a assert. And what does a login return? A login returns it should just be a 200. So we'll do a 200. Assert res.status code equals 200. All right, and let's test this out now. And it looks like we got an error. So what happened here? Let's take a look. It looks like we got a 422 as our status code. Why would we get a 422? And if we take a look at our logs, we don't really get much information here. So what I'm going to do is we're just going to print res.json so we can see what's going on. All right, why did we get a 422? Is there any other details it's going to provide us? So I'll do a -s so it prints it out. And we can see in the print statement, it says, oh, look at this. There's some sort of validation issue. Detail, lock body username message field required. Type value error missing. So remember, the field for the email when you log in is not actually called email. It's called username. So we have to fix that. So it's going to be username. All right. Now let's test this out once more. All right, we get another failure. So let's see. This time we get a 403. Okay, interesting. So what's happening? Why did we get a 403? Let's see. Detail says invalid credentials. Interesting. So if I go back to my login route, right, you could see that we get a 403 if the user doesn't exist, which means we couldn't find a user with that specific email, or if the password that was provided doesn't match what's in the database. So this is one of the issues. It's either the user doesn't exist, or the email doesn't exist, or the password's incorrect. So let's go into pgadmin, and if you left your database config so that you don't drop it at the end, instead you drop it before a test case starts, you should be able to see all of your test data. So I'm going to refresh this. And if I go to users, view, edit data, all rows, right? Well, there's no users. Well, that's interesting, right? Because if I go to my code, during our test create user, we should have created a brand new user. So why can't we log in as this user? Well, that's easy to explain. So if I actually go to my my database.py, we have these fixtures, and the fixtures have a specific scope, which means when do they run? And right now they're using the default function scope. What that means is they're going to run before every single function that's dependent on them. So that means when we run test users, right, we can see that test root client, right? Since we're passing client into test root, we're going to run our fixtures before we run this function. Then before the next test, we're going to run our fixture again. And then before this test, we're going to run our fixture again as well. So why does that actually cause the user to get deleted? Pretty simple. Because we run this test, right? The test create user. The user's in the database. And then we start to run the test login user. And so since we're dependent on the client fixture, we go to the database.py file. We can see that the client calls session. Session, what does session do? Well, it drops the database, or it drops all the tables at least, and then it creates all of the new tables. So we get a brand new database every single test that we run. That's why the user isn't there. And if you want to learn more about scopes, I recommend you go here, and then I think if I go to API reference, and then fixtures, let's go to examples. And go to fixtures right here. And then here I can search for scope. Here we can see the different scopes. So the default right now is that our scope is functions, which means that the fixture is destroyed at the end of each test and it's run for every single function. We then have a fixture that's set to a scope of class, which means that it'll run once per class and it'll run all the tests in the class. Then we have a fixture module. So when a fixture is set to a module, that means for all of the tests in a specific module, right? Like in this case, all of the tests here, we're going to run the fixture just once at the beginning, and then we're not going to run it again for that module. So all of the tests will have access to just that first instance run, essentially. And then we also have it for package, where it's going to run once per package. And then we also have session, where it's going to run once at the start of the testing session, and it's going to get destroyed. And you can see how we can set the scope right here. You just do scope equals, and then whichever one you want. So if we go back to here, and we see this fixture, right, we could say, since the default is function, it's the equivalent of doing scope equals function. And the same thing goes for the session, the database one as well. So these are going to run and get destroyed every single function. So at the end of the function, we're going to delete this test client, and then we're going to create a brand new one for the next one, which causes our database to get wiped and destroyed. So if we want our login user to be able to access what was created here, we could theoretically change the scope to be module instead. And I could change this for both. And so now what happens is at the start of this module, when we start running the tests here, we're going to run the fixture, right? Because the test root is calling it. So we'll run the fixture at the beginning, and we're going to just do it once. right? So then we'll call this one, which doesn't really do anything. We'll then create the user. But since we don't ever run the fixture again, we never end up running this session either. So we don't end up dropping our database or our tables. So we'll actually keep that same fixture, and then we'll run through all of our tests, and only at the end will we destroy that fixture. So we have essentially access to all of to our database for the entire module in this case. And so now if I actually run this, right, you can see all of our tests pass because the fixture will last the entirety of the module. I could even use package or session. Both of them would have worked. But this creates a little bit of an issue because this means that this test is dependent on this test completing. So if this test fails, then obviously this test is going to fail. And it actually creates issues because if I move this to the top, right, and I accidentally move my login user to before test create user, then this is going to break our tests once again because we need to create the user before we log in the user. And so in general, what we've done is bad practice. You don't want to make tests be dependent on other tests. Each and every single test needs to operate and run independently. They should not be reliant on other tests. If they are, it is not a valid test and you're doing it wrong. You want to make sure that all tests can run independently of one another. So what we've done so far with this little hack of changing the scope to be module is not a good solution. So in the next video, we'll take a look at what we can do to kind of overcome this limitation, this issue, so that we can make our login test case independent of our create user test case. Okay, guys, I wanted to make sure that we really did understand what scopes are when it comes to fixtures, because I feel like I didn't do that good of a job explaining it. So hopefully this video will help explain it a little bit more. And all I'm going to do is under our session fixture, I'm going to just do a little print statement right here that says my session fixture ran. And this is, I'm recording this video in the future, so I've got all of the other tests that we're going to cover done already, and I've kind of broken it out into test posts. So this is testing all of our post path operations. We've got one for users and one for votes. And I'm going to show you guys what happens when we use the default scope, which is it's scoped per function, right? This is the equivalent of doing scope equals function, which means that we're going to run this fixture for every single function that requests it. And so if I remove this, because once again, it's the default, and I run my tests, I want you to take a look at what happens. For every single test that we run, one dot represents the test, we can see it prints out. And so it's running through all the tests in test underscore posts, and then it's going to run all the tests in test underscore users and then votes. So you can see that because this is set to function, we're going to run this entire session fixture, this function, every single test that we have, or at least every single test that's requesting this specific fixture. That's why we see it run every single time. Now, if we change the scope to module, the behavior is going to be a little bit different. Now, if I change the scope to module, what's going to happen is that for every module that has a test that's requesting this specific session fixture, we're only going to run this fixture one time per module. And so now if I save this, and I'm going to no longer do -v, I'm just going to do just -s, so we can see this get printed out without too much extra data, because we're going to see a lot of tests fail, and that's perfectly okay. I want you to notice what's happening. So notice how the print statement ran here, and then the print statement ran here. And I had to cancel out of that because usually I end up with a ton of errors and then I lose my data. But you could see that the first module, which is tests underscore py, we could see that my fixture ran because it's because I told it to run because one of the tests is requesting it. Right? It runs, then one of the tests runs, and then the next test runs, and then the next test runs. So you could see that this is not printing out per test. It's only printing out one time per module. So when test the underscore post.py ran for the first time, and the first test required this specific fixture, it ran once. Then it didn't run for any of the other ones. That's why we see them all fail. And then the next module loads up, and we start running tests from there. So we run the fixture just one time. And then we don't run it ever again. So you can see I think it's 6 or 7 other tests ran with no other modules, with the fixture not running any other time. And then we can see the same thing for votes. We can see that my fixture ran just one time. So this means that it's going to run only once per module. We also have session. So if I do session, it's going to be even more different. You're going to see it run only one time for my entire testing session. So you can see my fixture ran. It's going to keep going through, which is perfectly fine. And then when we get to the next module, we should see it not run at all, right? And so you can see it didn't print again. So it's going to go through all of the different modules. And I'm going to cancel out of that before I get too many errors, right? But now it only runs once per entire testing session. So that's when the scope comes into play. So keep in mind, depending on what you're trying to accomplish, you may need to tweak the scopes of your fixtures depending on what they're supposed to be doing. But for our database, we want to keep it set to function, which is the default value, because we want to load up a brand new database by dropping our tables and then creating new ones every single time we run our test. So the default works perfectly fine for us. Now, to make our login user test independent of any other test, so it's not reliant on a specific order or setting the fixtures to be of a specific scope, what we want to do is before our login user test runs, I want to actually go in, define a function that'll get called, that'll actually create a brand new user so that we can actually test the login user out. And so, as soon as I said the words, I want to run a function before a test runs, the first thing that should click in your head is you want to run a fixture, or you want to create a new fixture. So we can actually create a fixture that'll create a test user for us. So up here at the top of this file, let's create a new fixture. And I'm actually going to delete this test. We don't actually need it anymore. It's just taking up space, or I can at least comment it out, I guess. And I'm going to define a fixture here. And we have to import PyTest. So we'll say import PyTest. And we'll say at pytest.fixture. And I'm going to call this test user. So it's going to be responsible for creating a test user. And this is actually going to make a call to our create user route. So we actually need access to client so that we can actually make that request. And there's 2 different ways of doing this, right? We could just have access to the session object. We can have access to the session object, and we can just, session dot, I think, what is it? Well, actually, no, it would be like models.user, and then pass in the data for a test user and then create it directly with the database. Or we could just make a call to our API and actually have it run through that. So I'm going to do that because it's a little bit simpler for now. But I'm going to define a dictionary with the data that I'm going to use for my user. So I'm going to have the email. And actually, it's going to be a little bit easier if I just paste this in. So we have the email set to something and then the password set to something. And I'm going to change this back to client. And now I can say res equals client.post, and we'll send it to users. And then the data for the new user can just be user_data. And just kind of like what we've done here, we can, just to make sure that this didn't error out, we can do an assert and just say, res.status code equals 201. If that's good, I think it's safe to assume we didn't run into any errors on the back end. But then what I want to do is, not only do I want to create the test user, I want to actually return the information about the user so that this login user will have the correct data to send when he tries to log in. That way, if we ever change this data, we should automatically update this data. So what are we going to return? Well, we have access to, to res.json. And if I print that out, we can just quickly take a look at what that looks like. And for now, I'm just going to return nothing, I guess. That's fine. I'll just return nothing. And here I'm going to change this to be, I'm going to pass in the test user. So that also runs. And so now this login user is dependent on two different fixtures, client and test user. And before we do anything else, let's make sure we clean up the scope. We don't need these to be set to that anymore. And if we run our tests, all right, the data we get back, we get the username. Oh, sorry, that's not what I want. This print. We get the ID, the email, and the created at. So what we'll do is I'm going to actually take this dictionary and I'm going to pass in the password as well. Because when I actually go to log in the user, I need to make sure that he has access to what my password is. But that doesn't get returned in the response. So what we have to do is we'll have to add a new field. So I'll say new underscore user equals, res.json. So we get that dictionary. And then we'll say new underscore user. We'll add in a new key called password. And I'll pass in user underscore data, which is this dictionary up here. And we'll grab the password from here. And what I'm going to do is then return new underscore user. And so anytime someone calls test user or anytime we have a test that's dependent on that, it's going to run this function. It's going to return the new user. And so now that we have the new user, what we can do is I can say the username is test underscore user. And then we'll grab the email key. And then the password will be test underscore user. And this will be password. Okay, and so that way, if I ever change the password up here, it's going to automatically get updated down here. So we don't ever have to worry about that. And one thing to note is that technically, if I deleted this and just called test user, right? Test user would technically call client, right? And that would go all the way back here. And then client would technically call session. So it would call all of these functions automatically for us. However, the one issue is that in this test, we still need to make a call with client. So we still have to pass in the client object so that we can make use of it. But I did want to highlight that because this fixture is dependent on client, it will run whatever code is in the client fixture. And because client is dependent on session, it will run whatever code is there within the session. So it's all done automatically for us, right? So the order, once again, is going to be we'll run session first, we'll then run client, and then we'll run this test user. So let's test this out now. Hopefully this works. And it passed. Perfect. Look at that, guys. We were now successfully able to log in a user. So that's cool and all, but I want to do a little bit more validation for the login user route, just to make sure that we got a token, the token is valid, and just do a few extra checks. So just like we did with the test create user, we can make use of the Pydantic model that we use for the response. So if I go into my auth.py under routers, and we can see for the login, the response model is set to a schema token. So let's import token inside our test users.py. So here, schemas, we already have access to schemas. And so I can say token, or what should I call this? I'll just call this login res, which equals, and then we'll call in schemas dot, I think it was a token. Was it token or token data? I think it was token. Well, let's just double check. It's token. Perfect. Okay, so token, and then what we're going to do is we're going to spread res.json. All right, so that's going to perform a little bit of validation. All right, and then when we get a token, I want to actually validate it. So how exactly do we validate it? Well, we want to decode the token. And so all of the logic that I'm going to implement here is essentially the logic that we use within our OAuth2 py file. So when we want to get the user, we want to verify the access token is valid. So how do we do that? All of the logic is right here. So we're going to decode the token, and we're going to make sure that the user ID is within that token. And that's all I'm really going to do at that point. So I will copy this. And we have to import JWT from, I don't know if it's Jose or Josie, who knows. So we'll import JWT. And what we'll decode is going to be in the login underscore res under the access token property. And then we have to pass in the secret key as well as the algorithm. So the secret key can be accessed with settings dot. Well, I have to import my config. So I'll say from app dot config import settings. So now we have access to our environment variable. So I'll do settings dot secret key. And then the same thing goes for the algorithm. So I'll set this to settings dot algorithm. So we're able to decode it. And then I'll remove this check. I'll just say ID equals payload dot get user ID. All right. And so once we get the user ID from the token, what we can do now is I can just assert does ID equal, and then is it going to match the ID of test user? So if we take a look at what test user was, that's coming from this fixture. And so it's going to return, oh, it looks like I did not, no, it should be in there. So since we grabbed the response, the ID should be there. So we can just call this test underscore user, and then we can just call ID. So I think that's a little bit more of a valid check because it's actually decoding the token just to make sure we didn't break anything there. And one more thing, we can assert login underscore res dot token type. So this should be set to bearer. All right, so let's test that out now. And everything worked. I think I've got one random print statement that I don't want, so I'll just remove that. And we have now successfully completed our login user test. Okay, guys, so before we actually create any more new tests, what I want to do is I want to create a special file under our test directory called conftest.py. So this is a special file that PyTest uses, and it allows us to define fixtures in here. And any fixtures you define in this file will automatically be accessible to any of our tests within this package. So it's package specific. So anything within the test package, even sub packages, will automatically have access to any of these fixtures. And the reason I want to do this is I want to take all of our database code, essentially, or well, our database fixtures, and I want to copy all of it. And I want to move it to conftest. And so by moving it to conftest, this fixture, the session fixture, as well as the client fixture, will all be accessible to, test calculations, test users, any other test files within the test folder automatically. And so now I don't actually have to import anything. So I don't need to import from conftest. It'll automatically do that. It'll automatically have access to client, and it'll automatically have access to session. And what I'm actually going to do is I'm going to move this test user to conftest as well. Right? And so that way, because I've imagined that even for other modules that I create, especially like for voting and creating posts, they're going to need test users as well. So it makes sense to put this in this conftest so everyone has access to it, and I don't have to go around constantly importing things around like that. And now within our test users, I should be able to leave everything else. And you'll see that we're not importing client or test user anywhere here. But when I run this, we should see no issues. So let's give this a try. And you can see all of our tests passed with absolutely no issues because we are importing those from the conftest file. And keep in mind, let's say I created a new package. I'll call this whatever. How about API or something? It doesn't really matter what I call it. And I've got a whole bunch of tests in here, test underscore something.py. Because this package is still within the test package, it'll have access to all of the fixtures in the conf test py. But within a package, I can also create a new conf test. So I can make a new conf test.py down here as well. And when I do it within this package, then test users doesn't have access to that one, but anything within the API package will have access to the fixtures in the API folder as well. So conf test is package specific. So every directory you create, you can create a separate conf test file so that you can essentially scope fixtures, or you can make it so that fixtures are automatically imported into certain parts of your tests and not others. But we'll delete that because I don't actually need that. All right, so we've finished our successful login user test. The next thing we want to test is for a failed login. So I'll do the same thing. I'll call this about test incorrect login. And once again, a few things need to happen. We want the test user so that a test user gets created so we can try to log in with his credentials, or at least with the wrong credentials this time. And we do need access to client just because we're going to be making a request. And here I'll say res equals client.post. And we'll say login. And for the login data, we'll say data equals, and then we'll do a dictionary. Here, the username, we can use, in this case, test_user email. And then for the password, we could just give it any arbitrary password. We'll just say wrong password because we know that's the wrong password. And so when a user enters in their wrong credentials, we should get a 403. So we'll say assert res.statuscode equals 403. And in the response, it should tell us that we have invalid credentials. So I'll say assert response.json. So we'll convert it to JSON. We will get the detail property, and that should equal invalid credentials. Make sure you get the capitalization correct because it's going to do an exact comparison. And just to confirm if that's what the capitalization looks like, it should be invalid credentials. So just copy it directly from here. And this should be res, not response. Let's try this out. All right, and the incorrect login worked. Perfect. So that means we did receive a 403, and we did receive the message invalid credentials. But not only do I want to test the wrong password, I also want to test wrong email as well. And I also want to test wrong email and wrong password and a few different things. So how do we do that? Well, we can use parameterize, right? So let's import pytest, which we already have. And we'll define our decorator. So pytest.mark.parameterize. So what are the properties that we want to pass? We're going to give it the attempted email, the attempted password, and then we could also get the status code. And we could also, match on a specific detailed message if you have a different detailed message for wrong password, wrong email, but we don't. So I'm not going to include that. And then now we'll just give an array with all of our, why does it do that? And so we'll define our tuples. And I'm going to copy and paste this part just because I don't want to have to make you guys sit through this, but I've got a couple of different test scenarios. So here I've got the email being wrong email at gmail.com with the correct password. We expect a 403. I've got the right email, wrong password. I've got the wrong email, wrong password. I've also got no email. So if you put none, this is essentially leaving it blank. So with this set to none, you'll see that our API actually will send a 422 because the schema validation fails because it expects a username or a password. And then we'll try sending it with the correct email, but no password at all. We should get a 422 in this case because Pydantic performed its validation and found that it was missing fields. So that's what I'm doing here. And then we're just going to update all of this. So the email, the email is no longer going to be test user. It's going to be, well, actually, first of all, we have to pass it into our function. So email password, and status code. So we'll say email, password is going to be password, and status code is going to be status code. And we'll get rid of this check just because the invalid credentials won't apply when we get the 422. So let's try this out now. Yep, and we can see all of our tests have successfully passed. So we have now finally set up a test for making sure that when a user does not provide the proper credentials, we get the right response code and the right data back. And keep in mind, guys, right, in this case, I just set this up to be a very simple test just to check on the status code, but you could check any single field that you want. It's up to you. You can make your tests as specific as possible. You can make them a little bit more generic. It's up to you to decide on what you want to validate yourself. And like I said, I'm trying to keep this as basic as possible. Try to just make sure that we focus on how to actually create tests and less on the actual specific tests. If that's all of the things that I want to do for all of the user tests, let's move on to all of the post tests. So tests when it comes to creating, reading, updating, and deleting posts. So I'm going to store this in a separate module just to keep things nice and organized. However, you can keep everything in one file if you really wanted to, but no reason to do that. So I'll call this test_post.py. Now, when it comes to working with posts, we do have to deal with a little bit of an extra challenge. And that is, if you take a look at all of our posts path operations, they all require authentication. So how exactly do we deal with authentication when it comes to testing? Well, you're probably thinking, we could, define a post, define a test, and we can call this, get all posts or something, right? And then here we can pass in client, and then maybe test user. So we have access to that. And then we would just do, client dot post login. So we log in, we get a token, and then after we get the token, then we can make a request to posts. And that is technically valid, but what I would like to do is I'd rather set up a fixture that automatically does this for us. But instead of actually making a request to our API, I want to just import the method, the OAuth2 method for creating an access token. So we could just import this into our test so that we can actually fake our own token or create our own token without having to use the entire API and go all the way through back into this same exact method to get a token, because that seems like a waste. And we're testing a whole bunch of other things that we don't want to test in this specific test. So what we're going to do is we're going to go to conf test, and I'm going to create a new fixture. I'm going to grab this, and I'm going to call this token. So we'll say token, and this is going to be dependent on test user. So we need a user to get created first before we run this fixture. And what we're going to do is we're going to import this specific function right here, create access token from OAuth2. And so I'll go from app.oauth2 import create access token. And just to quickly recap on how that function works, we pass in a dictionary, but I don't actually know what is in the dictionary. So let's go to, where is this? Who calls this? I think it's, no, it should be under users. Yeah. So create user. No, it should be under login. So under login, this is where we create the token. So we pass in data, which is just a property called user ID, and then we pass in the ID. That's all. Pretty straightforward. So we can do that. So I'll call create access token. And it's going to be a dictionary, and we call this, what is it, user underscore ID. And we're going to pass in, and we can get the ID of the user from test underscore user, which is being passed in, and we'll grab the ID property. And we'll just return this. So this is going to return a token, and that's why we call this function token. Then what I'm going to do is I'm going to create another fixture. I know there's a lot of fixtures here, but you'll understand why I want to do this. So I'll do def And here I'm going to call this authorized underscore client. The reason I'm calling that is if we take a look at our current client, this just gives us an unauthenticated client. This new fixture will give us a authenticated client. So anytime we want to deal with any path operations that require authentication, we can just call this client the authorized client instead of the regular client. So that's going to save us a lot of time. And this is going to require the regular client and token because we need to get a token. All right, so we have access to the original client. And what we can do is we can update the headers because we need to pass the token inside the header. So we do client.headers. And then we have to pass in a dictionary. And what we want to do is we want to spread out all of the current headers. So we do client.headers. And then we want to add one more, which is going to be the authorization. And this is going to be an F string because we need to add the word bearer before it. And then we can pass in token. And then we'll return this client. So it's basically taking the original client and then just adding this specific header that we get from the token fixture. That's all. And so now when we go into get all posts, and I forgot to put the word test before it. Instead of client, we want to import authorized client. And we don't necessarily need test user at this point. It'll automatically get called because, this calls token, token calls test user. We only need to pass in test user if we want access to specific user data, but we're not using any of that information at the moment. So I'll do authorized client dot get, and it's going to be /posts. We'll set the response equal to that. And we'll just do a print res.json just to see what that looks like. And I believe the status code should be a 200 because we're retrieving data. So I'll do res.statuscode equals 200. So let's just take a look and see what exactly is happening here. And now it's going to be test posts. And we get an error. So let's see what happened. Authorized client not found. So I think I forgot to save. Let's try this again. And I forgot to turn this into a fixture. So right now it's just a regular function. So let's make sure I add the fixture there so it's accessible to everyone. And now if I run this. Okay, so one passed. Let's take a look at the data that we got back. So when I did a print of res.json to see the data, I got an empty array. And the reason we got an empty array is that there's no test data in our database. There's no test posts. So we're going to have to actually create some test posts before we run this test so that we can actually verify that we got what we expected to get. So just like we did with the login user where we created a test user before, we're going to have to do this with our posts. We need to create a whole bunch of posts and then verify that we are able to retrieve those posts. So we'll tackle that in the next video. So let's create a fixture that will create a few initial posts so that we can actually test retrieving all posts. And we can use that same fixture for performing a few other tests. So things like updating a post, right? We would need to have a post in our database to update a post. Same thing with deleting. Same thing with getting an individual post. So this fixture is definitely going to be very reusable across a lot of our tests. So let's figure out where we want to store our fixture. We could keep it in our test.posts, test_post file, because all of our posts, all of our test posts, our tests for post data, I guess, if you want to call it that, will require that fixture probably. However, there are going to be other tests in our application that will need posts initially. So when you want to vote, we need a post already in our database. So I'm actually going to put it in our conf test file so that everyone has access to it. Well, technically anyone can access any fixture if they import it, but having it in the conf test file makes it simpler because we don't have to import it. So I'm going to put it in here. And this fixture is going to be a little bit different just because we're actually going to create the posts in the database ourselves. So here I'm going to call this test underscore posts. And so what we need is a couple things. So first of all, we need a test user, because if we don't have a user, we can't create posts, because all posts need to be associated with the user. Since we're going to work with the database, we're going to pass in session also. All right, and let's define some post data. So I'm going to create an array of dictionaries. And I'm actually going to copy and paste some data just because I don't want you guys to sit and watch as usual. All right, so what we're doing here now is we're creating 3 posts. So in this post data, I have an array, or sorry, in a list, and then a dictionary, and then here we're providing the title and the content and the owner ID. All right, so that's going to create a post, and we're grabbing the owner ID from the test user fixture, and we're just going to grab the ID from that. So we're setting the owner ID, and then I'm just going to create another post here and another post here. So the same user is essentially creating 3 posts. And so now, since we have access to session, we can actually just directly tap into our database and create that information for us, or those posts. So we can do, when it comes to SQL Alchemy, if you want to add multiple entries into a database, we have access to the add all method. So we can call session.add_all. And then here we have to pass in a list of user models. So this would be, schemas. Sorry, not schemas. We'd actually have to import models. So I'm going to import. Do I have models already in here? Doesn't look like it. So I'll import that as well. So we'll say from app dot. Let's just say from app import models. And I can say models.user. So we'll create a new user model, and then we have to pass in all of this data. So, right, we would need to be title equals, blah, and then content equals blah. And then we'd have to do another one. So I'd copy this, paste this in here, and so on. And then this would add it all at once. Now I can manually hard code this value into here just to kind of keep things simple. And I could do that. And actually, I will show you how to do that just in case. But I'll show you what I did when I was doing a dry run. So I'll copy the title. This is going to be set to first title. The second title is going to be here. Content. And second content. And then the owner ID is going to be the same for both, luckily. Well, all 3 actually. And that's not in the right format. Oh, don't do that. It should be equals. And the same thing here. And if we wanted to, we can copy this last one and then put the third one in. This will be called third title, third content. All right, let's save this. The auto formatter did not do much to help me out here. It still looks pretty ugly, but that's okay. And so that's one way of doing this. So it'll add it all. And then all we have to do is just do a session.commit. And then to get all the data back, I can just do a session.query. And we'll just say models.post. Oh, this should be user, by the way, not. This should be post, not user, because we're creating a post and not a user. We'll say models.post. And we can just grab all of them. Now, if you wanted to be able to take this dictionary and convert it easily to this format, there's a couple things you have to do. But technically, you could just leave it like this and it'll work fine. But this is a little bit more of Python than anything else. If you didn't want to hard code it in like this, because at this point we don't even need this dictionary. But if you wanted to take this dictionary and convert it into a list of user models, post models, what we can do is we can use the map function. And so the map function works like this. You call map, then you call some function that you define yourself, and then you call the posts underscore data list that we have up here. And so this function, what it's going to do is it's going to iterate through this list, and it's going to take each item in the list, which is a dictionary, and it's going to convert it into a models.post. So how exactly does that look? Well, first of all, let's rename this. And I'm just going to call this maybe create user model. And I'll define a function up here. And I don't know why I keep saying user. It's a post. We're creating posts, not users. Create post underscore model. And this is going to get passed in some object, but technically what's going to get passed into this function is each dictionary. So I'll call this post underscore data. Well, actually, don't call it post data. I'll just call this post. And so we have to put the logic of converting a dictionary into a post model. And that's pretty easy. All we have to do is just say models.post. And then we take post and then we spread it. That's it. All right. So what's happening here is we're taking a dictionary, which is what it's going to get passed into here. And then we're taking it and spreading it so it looks like title equals blah, content equals blah. And then we can just return that. And then this map, we just set it equal to some variable. I'll call this maybe post map. And I'm forgetting an E. Okay, so that's going to return. So that's going to essentially convert all of those to user models, but it doesn't return a list. It returns a map, which isn't quite the same thing. So to convert it to a list, all we have to do is then say posts equals, and we just say list, and then post underscore map. So that'll convert it to a list. And then under session.addAll, instead of hard coding those values, I could just say session.add underscore all, and I just pass in posts. And we can just comment out this line right here. Either one works. Choose whichever one you like. I don't really care. But this is all we need to do. We just have to return this. So I'll save this as posts. And we'll return posts. And that should create 3 posts in our database. And so now if I go to test posts and make this reliant on, what did I call it? Get test posts. If I then run this, right, you can see that we did in fact get multiple test posts. And it's up to you to decide what checks you want to perform. If we go to our post route and we take a look at the schemas, you can see that it's going to be of type list of schemas.postout. List comes from the typing library. So let's see if we can actually do this. I never actually tried this with this, but I think it should work. So I will import that. And then we'll also import from app, import schemas. And I'll just say posts equals res.json. And I'll say actually schemas dot, what is it? Post out. Yep, it's going to be post out. I don't think that'll work because, this is expecting one individual post, but this is going to be a list of posts. So I wonder if I can do, we'd have to do this manually. Like we'd have to iterate through it and then basically copy it out. And I think that would just take too much work. So we'll leave this section out. If you guys want to take that as a challenge, you can essentially create a post pydantic model for each entry within the response, and then try to validate each single one. So instead, I'm just going to do a simple check. I'm just going to say assert, and we'll just grab the length of response.json, and I'm going to set this equal to length of test_posts, just to make sure that we get 3 exact posts. And if we ever change the number of posts that we have, this should automatically get updated. I think that's a good enough check for this test. So let's try this again. And we shouldn't get any errors, and it looks like it passed just fine. All right, guys, so I figured, you know what? Let me go ahead and just show you how we can actually do the validation using our schemas. We're going to use the same exact logic that we use here when it comes to performing the map, because we're essentially going to take a list of dictionaries and convert it to a list of schema models. So we're going to go back to our test. And what we're going to do is we're going to first define a function that's called, we can call it validate. And this is going to receive a post. And that's going to be a post, that's going to be a dictionary that we get back. And all we're going to do is we're going to return schemas.postOut. And here we're going to pass in the data. We're just going to unpack it with post. So that's all we have to do. And then we can call the map function like we did before. And I'll store this in a variable called posts_map, which equals map. We're going to call the validate function, and we're going to pass in res.json. And so we have a map. If you wanted to, you could technically convert it to a list by calling list post.map, but we're not doing anything with that data. However, just to show you, we can just print this out real quick. And so now if I run this and we take a look at the print statement, you can see we've got a post out model, and it does all the validation. So it's going to make sure all of the properties are set and are there. And because we have it set as a post out pydantic model, you'll see that it's very easy to perform extra checks with the assert statement. So now I can do other checks like maybe I want to say, actually, let me first save this as a variable. I'll say posts list equals list of posts map. Ooh, and that's supposed to be post map. So we have access to this list. And now what I can do is I can just say assert. And here we can grab posts_list, grab the first post. And we can check certain fields. I could say like, hey, does the ID, it's going to be the post.id. Does that equal test_posts? We'll grab the first object and then grab the ID. Well, actually, it's going to be, I think I could do just .id. Yeah, because test post, keep in mind, when we do test post, this is going to return, not a pydantic model or a dictionary, but this is going to return a SQL Alchemy model. So a little bit different, but we just call it .id, and I think this should work. So let's test this out. It did not work. What happened here? Yep, so I accidentally grabbed, I see, yeah. So this is expected just because I don't know the order that we're going to retrieve the posts in. I didn't provide a order by filter criteria when it comes to my get post functionality. So it could be returning any post. So right now it's saying that, hey, this ID happens to be 2. This one happens to be 1. So the order doesn't matter. So this isn't exactly the best way to do it. But if you want to figure out a way to set up the order so that you always receive maybe the post with the lowest ID and then you compare the two, that would be perfectly fine. And then you can check other properties like what's the title? Does it match up with what we should expect it to be? Does the content match up with the content? You could put as many asserts as you can. But by doing this, we are able to perform a validation to ensure that at least we get what we expect. All the fields are there, and then it's just up to us to set up the necessary asserts to verify that the values are correct. But I'll remove that, and I think it's okay just to keep it like this for now. All right, so we set up a test for getting all posts, and what I want to do now is I want to test to make sure that a unauthenticated user is not able to retrieve all the posts. So I'll create a new test and I'll call this test. How about unauthorized user underscore get underscore all underscore posts. And instead of using authorized client, because we want to test if a unauthenticated user tries to access it, they get a 401, we'll just use the regular client, which is going to be a non-logged in user. And we want to make sure that test posts are here as well. And remember, because we're calling test posts, that's going to ensure that because test post is reliant on test user, it will in fact create a test user as well. So just to give you a heads up, we don't actually have to pass in test user into here because this should handle that automatically. And here I'll just say res equals client.get, and we'll just go to posts again. And I'm just going to assert a simple 401. So res.status code equals 401. That's really the only check I want to do. If they're unauthorized or unauthorized, there's no other things to check really. And we can see that it did successfully pass. Okay, so we've tested the get all posts. We're going to now move on to getting an individual post by an ID. But before we do that, I think it's best to actually test getting an individual post by ID when you're an unauthenticated user, because we can essentially just copy this code. And I can just paste it here. Instead of doing a user get all post, this will be user underscore get one post. And so everything else can be the same. We just have to change the specific URL. And so in this case, we're just going to grab the ID of one of the posts. So here, I'm going to change this to an F string. And I'm going to say test underscore posts. We'll grab the first one. And then remember, this is a SQL alchemy model. And so we actually have to convert it to a dictionary. So we have to do dot underscore underscore dict underscore underscore. Sorry, the test posts is not a SQL. Is it a SQL? I think I could do ID. I think that should work actually. Never mind. I think we should be able to do that. That should be fine. And this should be a 401. So let's test this out. Let's make sure that this works. And that works. And what I also want to do is I want to test for a post, to retrieve a post with an ID that doesn't exist, I guess. So I'll call this a def test get one post. How about not exist? So this one, we're going to need an authorized client. And then test underscore posts as well. And I'm going to copy this. But we're going to change this, and I'm going to hard code some random number, like 88888. And then we'll just assert res.status underscore code equals 404. All right, so now we're going to try to retrieve a post that doesn't exist, and it looks like it passed perfect. So now let's actually try to retrieve a valid post. This one's going to be a little bit more work. So we'll say def test get one post. And we're going to copy these two. And I'm going to copy this one right here. So we're going to retrieve the first post from test post with an ID of 0, I think. And I'm just going to rename this to authorized client. And let's just do a print. Let's see what this looks like. So we'll say res.json. All right, and that's going to run. And it printed out the post so we can see what that looks like. And just like we did before, we can also do a validation. So I can say post equals schemas dot, what is it? I think it's post out. Yeah, post out. And we're going to pass in res.json. And do we need to unpack it? I think we have to unpack it. Let me print out post just to see what that looks like. Actually, I could just take a look at what we did up here. Yeah, we have to unpack it. Or spread it, whatever it's called. Yep. So now we've got our post model. Well, it's our pydantic model. And so that does some level of validation. And then at this point, what we can do is I can say assert, and I could say does post dot, and then take a look at the format. We have to grab the post property. Actually, it's this first one. Yeah. So we'll grab post.post.id equals. Then we're going to compare it to the ID from test_posts. So it's a test_posts 0.id. And I think that should still work. All right, that works. And we can check a few other things. So we can say post.post.content. And if you're wondering why it's post.post, remember, if you actually take a look at our schemas, our post out, you can see that we have to grab the information about the post, we have to go into the post property. And then from in there, we can then take a look at all of these fields. So that's why we have to do it like that. And we'll say test_posts 0. And then let's see if we can do content. I believe this will actually throw an error because this is a SQL Alchemy model. So it's going to, oh, that actually did work. I'm surprised. Okay. All right, that worked. So if you guys want to, you can also essentially copy this line and then check to see if the titles match. You can essentially check every property if you really want to. So we'll just run that one last time. Perfect. And I'm just going to remove this print statement. And so those are all of the tests that I want to do when it comes to retrieving an individual post. I think I'm sure there's a couple of tests you guys might be able to think of, so feel free to implement that, but I think that's a good starting point on this. But in the next video, we'll take a look at creating a post. Okay, so let's move on to creating a post. I'll create a function. We'll call this test create post. And we're going to need an authorized client. We're going to need a test user for sure. And lastly, this is purely optional. If you want to, we could also set up all of our test posts if you wanted some posts in the database before you created one, just to potentially see if you run into any issues when it comes to creating posts when there's already posts. But it's optional. And we're going to set the res, and we'll set this to authorized client.post. And the URL is going to be /posts. And then let's give all of the data for our new post. So we'll say JSON equals title. And you know what? Instead of doing this, let's go ahead and set up a pytest. What was it called? I already forgot what did we call it? A parameterize. So mark parameterize so that we can test multiple different values. Mark dot. Why is that not working? Okay, I have to import pytest. And we don't need this line right here. So we'll say import pytest. And so what are the values that we need? How about title? We need title for sure. We need content. And then we can also give a published value if we wanted to. And then let's give all of our, come on, VS Code, don't do that. All right. First tuple, what do we want the title? How about awesome new title? Ooh, awesome new title. What's the content? Awesome new content. And what do we want published to be? How about true? And we're going to copy this, and I'm just going to put in some new values. favorite pizza. And we'll say, I love pepperoni. Ooh, published. Let's say that's still a work in progress. Tallest skyscrapers. All right, so we've got some test data. Let's pass those values in. So title is going to be set to title. Content is going to be set to content. And then finally, published will be set to published. All right, we get a response back. Let's do a little bit of validation with our Pydantic model. So I can say schemas.post. And we'll just take the response, convert it to JSON, of course, and set that to created_post. And then we can just run a couple of checks. So let's assert the status code. So for creating a new post, it should be a 201. And then for, we could just assert a few extra values. So I could say like res dot, actually I can grab created_post dot title should equal title. And I can just do that. Whoops. I need 2 equals. And then I can just copy this a few times. We'll change this to content. Content. And then published. And while we're at it, we could also verify that the owner ID gets set. So I can say created underscore post dot owner underscore ID equals, and then we can grab test user ID. So I think that's a good number of things to check. So at this point, I think it's safe to say that all of these should work. All right. And all of those passed. Awesome. So we've got the create post done. There's one other thing that I want to test with create post because if you go back to our, what is it? Our schemas. Where's our schema? I don't know if we have a create post create. So that's just going to be from post base. We can see published is set to a default value of true. So let's test to see if the default value of true gets set. And we theoretically could have put this test in here just by doing a none here, but I like to separate this out into a different test because we are testing a different functionality in this case. So we'll say test create post default published true. I'll do authorized underscore client and test user. Once again, we don't need test posts, but if you want to have it in the database just to make sure that everything's not broken when you already have posts already in there, we can keep that in. And I'm just going to copy this. Actually, I could essentially copy all of this. And we could just give it arbitrary titles. And then published, we'll leave out published. We don't want that anymore. And I'll just copy these values here. And published should be set to true by default. So even though we're not passing it, it should get set. And everything else should still be just fine. So let's test that out. Oh, it looks like it failed. So what happened here? Oh, I just pasted in the wrong values. All right. And then one last thing, just like we did for all the other routes within the post, we also want to test if we're not logged in. So I'm going to copy this one and just rename it. So test unauthorized user create post. We don't need to have test user in there, but why not? And I'm going to just copy this right here. And then just change this to a plain client. All right. And this should work. All right. And that passed as well. So we have got all of the create post tests done. And I think in the next video, we will tackle either deleting or updating a post. Okay. So let's move on to deleting posts. And the first thing that we're going to do is we're going to test a unauthorized user trying to delete a post. So we'll say test unauthorized, oops, delete post. And we'll have client test underscore user. And we'll definitely need test post in this case. And then we can essentially copy, well, I'll copy this one right up here. And we'll change this to, we don't need the body anymore. And the route is going to be, we're going to pass test underscore posts 0 dot ID. All right, let's test that out. Yep, and I realized this should be a delete actually, not a post. That's why I got some other status code. Perfect. All right, so we got that one to pass. And so now let's test a valid deletion. So I'll say test delete post. And ideally, I guess we should be calling it like success, like we successfully deleted it. And this time we'll get the authorized underscore client. We'll get the test user and the test underscore posts. All right, we'll call this same request here and just change this to authorized client. And this should give us a 204. I mean, you theoretically could also, then fetch all posts again just to verify that the total number of posts is one less, but we're not going to do that in this case. You could, however, do that. And that failed. So what happened here? A 422 and two things. So I don't even know how this one ran with the same issue. We need to make that an F string. So I genuinely don't know why that actually worked. Little alarming, but let's test both of those out. All right, all of them passed. So we've got that done. Let's test deleting a non-existent post, so an ID that doesn't exist in our database. I'll say test delete post non-exist. And I'll just copy these. And I'll copy this. Actually, I'll just copy all of this. And I'll just change this to be some ridiculously high number. And this should be a 404. All right, that one looks good. All right, so the next one's going to be a little bit trickier. We're going to create a test where a user tries to delete a post that isn't theirs. So they try to delete a post that's owned by someone else. So we'll say test delete other user post. Now, there's a couple of issues here. So first of all, we need to actually have more than one user in the database, and we need to have posts owned by multiple users now. So this creates a couple challenges. So how exactly are we going to set up more than one user? Well, I think it's best to use fixtures like we always have. And ideally, I would have set up a test user. Where is it? My test user. I would have set up a test user to actually create multiple users in our database, but I didn't. So I just have one. If we had set it up so that multiple users are in the database, then this test would be a little bit easier. Since I didn't, what I'm going to do is I'm essentially going to copy this. I'm going to copy this. And right above it, I'm going to create just a second one. I know it's not very original. Probably not the most efficient way of doing things. And it's going to be dependent on client. And we're just going to put a 1 or something. It doesn't really matter. Just so that we have another user. I'll make this 1, 2, 3. And so now we have 2 users, which is perfect. Down here in my posts data, what I'm actually going to do is I'm going to create one extra post. And we could just copy this data right here. And here, I'm actually going to pass in an extra fixture, which is going to be test underscore user 2. So before test post gets created, we're going to create the second user. And here I could just grab the ID of test user 2. And actually, I don't even need to do that. I don't know why I did that. We don't even need to create a post owned by that user. We'll leave it like this for now. Nope, I was right. Actually, we do. I don't know why I'm flip-flopping like this. So the fourth post, 1, 2, 3, 4, is going to be owned by test user 2. And so now if I go back to test posts, here we're going to be logged in. Remember, authorized client is always going to be logged in as user 1. So we're going to try to delete that fourth post. And so we can do that by grabbing the ID of the fourth post. So we'll say test underscore, need curly braces, test underscore posts. We'll grab the fourth one, which is an index of 3. And then we'll grab ID. And this should, I forget what kind of error it should get or what status code. I think it's 403. So we'll do assert res.status underscore code equals 403. And it looks like that successfully passed. And so that one's good. And that pretty much wraps up all of the delete tests that I want. And then in the next video, we'll take a look at updating posts. All right, so let's update a post. I'll say def test underscore update post. Here, we need an authorized client. And we'll need a test user. And we'll need test underscore posts. All right, and I'm going to define a dictionary with the values that I want to update. And so here I've got the title, the content, and then the ID, which I'm grabbing from test posts. And I'm just going to use the first test post in there. And I'll say res equals authorized client dot, I think it's put. And then we're going to do an F string. And we'll say slash posts. And this one will be test underscore posts 0.id. And then we have to pass in the data. So we'll do JSON equals data. So we're passing in this dictionary. Right. And just like we do with the other routes, if we go to the update post, Technically, we're sending it out with the schema of post, so we can just quickly validate it on our end on the test as well. So I can say updated post equals schemas.post, and we'll pass in res.json. And then we can assert a couple things. So we'll say res.statuscode is going to equal, what's an update? I guess we use 200 in that case. And then we can assert a few things. So we want to make sure that the new title, we can do updated underscore post dot title equals data dot updated. Data dot, this is a dictionary, so title. And we can do the same thing for the content. And I think that should be everything that we need. And just to, just to make sure that my tests don't take too long, I'm going to start commenting out all of my other code, all of my other tests in this file, just to make things a little bit quicker. But you can see how it starts to slow down just with just a couple of tests, really. So we can see that it did successfully pass, so that's good. We've got the first update post test. The next thing I want to do is I want to try to update another user's post. So we'll say update other user post. So this, we need authorized client. We need test user. And we need test user 2. And test underscore posts. So we're going to try to update that last post. And so I'm going to define a dictionary with the values I want to update it with. So same thing, title, content. The only difference is the ID is going to be, I think it's actually 3. So the ID is going to be of the fourth item in that list. And I just want to make sure it's the fourth one. So 1, 2, 3, 4. So yeah, we need a value of 3. And I'm going to copy this. And just change this to 3. And we should get a status code of 403. And let's test that out. Perfect. And the last thing we need to do is a unauthenticated user trying to update a post. Actually, there's 2 more tests. So let me grab unauthorized user, this one right here. And this is going to be a put. And that should return a 401. And the last thing that we need is, and actually I need to update this name. So unauthorized test update post. We can also set up a test to update a post that doesn't exist. And I believe we can just copy the deleting the post that doesn't exist. Delete post non-exist. So I could just copy this one. And change this to a put. And we'll change the name to be update. And let's test this out. Hopefully everything works. Oh, one failed. What happened here? Okay, so it tries to validate it because I didn't provide any data. So I can just copy this data right here just so we can give it something. And so we can say JSON equals data. That's going to prevent us from getting validation errors. And that passed. Perfect. So let's take all that. I'm just going to uncomment everything else so we can get all of our tests back. And that's going to wrap up updating posts. And that's actually going to wrap up all of my post cases. And so I guess the last thing that we got to do is set up all of the voting tests. And there's only going to be a couple of voting tests, but it should be fairly quick. All right, so let's move on to setting up our tests for voting. I'm going to create a new file. We'll call this test_votes.py. And let's define our first function. So I'll call this test vote on post. So this is going to be a successful vote on a post. What do we need? We need an authorized client, of course. And we need to make sure that there's some posts already in our database. All right, and now I can do a authorized client post. And here, this is going to be the vote endpoint. And let's just give it some data. So here, we're going to pass the post ID. So this will be post_ID. And we'll grab the first item in our list, testpost.id. And I forgot my curly braces. That's why it's giving me an error right now. And we'll say, what is the direction. So we're going to be voting. So this is going to be dir set to 1. All right. And now technically, if you look at what's happening, right, we're logged in as user 1. And test posts, and if we go back to that fixture, where is this guy? That's owned by user 1 as well. So technically, we're voting on our own post. But if you look at our code, we didn't actually put any checks to stop us from liking one of our own posts. So it's perfectly fine in our test to do that just because our code is right now allowing it. If you didn't want to do it, then first of all, we'd have to update this code to make sure that we perform a check to verify that, hey, are we voting on our own code? If so, voting on our own post, then we should reject it, but we don't have that implemented. So for our test, it's perfectly fine because that's how our application works. But obviously, if you wanted to make sure that you're testing someone else's post, then you could just obviously pick the last item, so the third item in the array, because that's owned by test user 2. You just would have to make sure that you pass in test user 2 in this case, just to make sure that he gets initialized. But that's a good assignment for you guys. I would see if you guys can implement logic to make sure that you can't vote on your own post, and then go ahead and create your very own test to make sure that if a user tries to vote on his own post, he gets an error of some kind. But for us, this is good enough. I'll leave it as 3 just so we're voting on someone else's post. I'm okay with that. And we can just assert res.statuscode equals 201. Don't really need to check anything else. And now I can just change this to test votes. Okay, so that one successfully passed. All right, the next thing I want to test on is what happens when a user tries to vote or like a post that he's already liked. So we'll call this a def test_vote_twice_post. And so we'll need an authorized client. We'll definitely need test posts. But there's one little issue with this one, right? We need to have a post that's already been voted on. And we don't have that right now. So how do we do that? Well, I mean, theoretically, we could initialize our test post fixture with some votes. But instead of doing that, I'm going to actually create a new fixture. And I'm going to keep it in this file because all this fixture will do is it will set up one of our posts to have a vote on it already. And I don't think really anybody else in any other test in our application is going to need that outside of the voting file because that's the only one that's concerned with voting. So let's test that out. So we'll import pytest. And we'll set up our fixture. So pytest.fixture. And I'll call this test vote maybe. And so for this fixture to work, we definitely need an authorized client. Actually, we don't need an authorized client. We'll need test posts. We'll need a session because we're going to just change it in the database directly. And then we'll need our test user. And so let's, we're going to have to import our models. So I'm going to say import, not import, from app, import models. And I'm going to say models.vote. So let's create a new vote. So we're going to have to pass in the post underscore ID, which is going to equal test underscore user. We'll grab the third one, .id. And then we need to pass in the user ID, which equals, it looks like we already have the test user. So I can say test underscore user ID. And then I can just do session.add new vote. And I need to create a variable or store this in a variable. So new vote. And then we can do session.commit. And so down here, I can pass in test underscore vote. And I'll say res equals authorized client dot post. And then JSON equals, what is the post ID? We'll grab this from test underscore posts. Grab the third. And we'll grab the ID. And then we'll set the dir to be a 1. So we're trying to revote on that vote. And we should get a 409. So we'll do assert res.statuscode equals 409. All right, let's test that out. One error. Oh man, what happened here? That's a key error, so something very simple happened. Yep, and I see my mistake. This should be test posts. All right, let's try that out now. And that worked. Perfect. All right, now let's try successfully deleting a vote. And so we will need all of these. We'll also need a test vote. And so we do res equals authorized client dot post once again. I'm just going to copy all of this. So we got that. And then the direction is going to be 0 for deletion. And then we just need to assert res.statuscode. This is going to equal, I think we just left it as a 201. Okay, so that worked. And then now we want to delete a vote that doesn't exist. So unlike a post that we never liked. So we'll say def test underscore delete vote non-exist. So we'll need the same exact stuff right here. Okay, I'm just going to copy all of this for now, and then we'll change up the few details. Direction 0, same post. But I'll just grab, actually, we don't want the test vote because we want to make sure that there isn't a vote. So we're going to remove that fixture. And this should be a 404. Let's try that. That worked. And then finally, let's try voting on a post that doesn't exist. So we'll say, liking a post that doesn't exist. So we'll say def toast test vote post non-exist, and copy all of these. I copy this, set the direction to 1, and the ID is going to be 8,000. And we expect the status code to be 404 as well. All right, it looks like everything's good. The last thing that we just want to check is make sure that a user who isn't authenticated can't vote. So I will copy this. Test vote unauthorized user. And then we want just the regular client in this case. We'll do test posts 3.id. And this should be, was it a 401? I can't remember. Let me go to the other one. It should be 401. Okay. All right, guys. So I think we've covered all of the tests that I wanted to cover. We don't need this test calculations py file, but I'll keep it in there in the repo just so you can take a look at it. The database.py file is absolutely useless now, so I'm actually going to just delete. I'll keep it in there just in case you want to see it, but most of it's moved to conf.test.py. But just to make sure that everything's still working, I'm going to run my tests for all. Ooh, what happened here? Nope. Oh. Okay, yeah, that was wild. All right, remove this. Let's see what happens. Hopefully everything passes. And all 46 tests have successfully passed. So that pretty much wraps up all of the testing section. I recommend you guys think of different scenarios that could potentially break our application and set up tests for each and every individual scenario, because that's how you successfully set up tests, because you want to make sure you cover every individual corner case that you can possibly think of. Currently, when it comes to adding in new features and making changes to our code, we have to go through a very manual and cumbersome process before we can get those changes pushed out to our production environment. And so what I think would be good is for us to set up a CI/CD pipeline so that we can do all of this in an automated fashion. So I've created a couple slides just to kind of go over what our CI/CD pipeline is going to do. And I've got the generic definition of CI/CD, and it's probably not a very good definition. And I was thinking about just leaving out the slide because it doesn't really provide much, but I figured I'd just add it just in case. So CI/CD stands for continuous integration and continuous delivery. So continuous integration is the automated process to build, package, and test your application. And then the continuous delivery picks up where your continuous integration ends and automates the whole delivery of the application. So continuous delivery is responsible for actually pushing out those changes to your production network. So those two things make up our CI/CD pipeline. But let's actually take a look at what our whole manual process looks like right now so that we can see where a lot of the extraneous time consumption and manual process takes place. So our current manual process is that, we're going to make some changes to our code, and then we're going to commit those changes to Git, right? Because, we don't want to lose those changes. And then after that, we want to go ahead and run PyTest so that we can verify that our changes didn't actually break any known functionality to our code. And if our tests pass, we have an optional step of, building any images. So things like Docker images, if we happen to be running Docker in our development and production environment. If we're not, then this is an optional step. However, when it comes to the build phase, in this case, that some people referred to, other programming languages might require you to kind of build the application at the end to actually be able to deploy it. Python, you don't really need to do that. So that's why it's kind of an optional step here if you're not using Docker. But after we do that, we then move on to deploying our application. So I just have one row called deploy here, but keep in mind this one little block could represent multiple steps, because depending on how you actually deploy your application, making any changes or updating the code in your production environment could actually involve a very complex process. So with with Heroku, right, it's obviously a very simple process because all we do is we just do a git push to Heroku, and that's going to automatically cause Heroku to kind of handle all of the updating of the processes. So that's a feature that's built into Heroku, but we only get that if we use Heroku. There's obviously a number of different ways that we can deploy our application. If we decide to go the route of deploying our application on an Ubuntu server, then the deployment process in this case would be us logging into our server, us pulling in the new code with the changes, and then restarting the service so that our application actually uses the new code. But if you're using, some other production environment or you use some other method to deploy your application, this could be an even more complex process, something to keep in mind. So even though it's just one block listed here, it could actually be, numerous steps. All right, and so now I want to show you guys what our automated CI/CD pipeline is going to look like after we set it up. And so just like we did in the manual process, we're going to make changes to our code. Obviously, that's a manual step because we have to implement the changes to our code. And then we're going to commit those changes. And with a CI/CD pipeline, or specifically with the one we're building, that's all the manual steps that we have to do. We are done. We don't have to touch our keyboard or our mouse. It's basically hands off at this point, and we're going to let automation take over. And so usually when you commit changes to your code, that's going to trigger our CI/CD pipeline to run. And so what happens is our continuous integration phase starts at this point, as soon as we commit those changes. So in the CI phase, we do the first thing that we do is we pull our source code. So we pull our source code so that we can actually work with it. We then install any dependencies. So this is the equivalent of installing all of the dependencies listed in our requirements.txt file. We then run our automated tests. So that's running pytest. And then, assuming the tests pass, we then build any images. This is once again an optional step for us. That's only needed if we use Docker. But that wraps up the continuous integration phase. So once that's done, the continuous delivery phase is going to take over. And so the continuous delivery phase, what it's going to do is it's either going to grab the latest code or the new build image, depending on what our deployment model actually is. And with the new image or code, it's going to then have all of the logic needed to push that new image or the new code into our production and make sure that our production is actually using our brand new code. And so these two steps are really the only manual steps. The continuous integration and the continuous delivery phase is all done in an automated fashion through code, essentially. And so some of the more common CI/CD tools include Jenkins, Travis CI, Circle CI, and GitHub Actions. Now, for our course, we're actually going to use GitHub Actions just because it's already integrated into GitHub. It's free. We don't need to install anything on our local machine. There's no software that we have to set up because it's all hosted on GitHub. So it's like a hosted service, and it's just going to make things very clean, very simple, and it's free. So it's going to make, and so everyone will be able to have access to it. So what exactly is a CI/CD tool? What does it provide? And so every time I heard CI/CD before I learned what it is, I always thought it was like a very complex thing. And then when you find out what it actually is, it's actually this stupidly simple. Right? There's no magic behind CI/CD. It's all very manual, even though it's an automated process. You'll see that when we actually go to configure it, it's not really doing anything special. It's doing everything that we already do, but we're just providing instructions to a machine. So a CI/CD tool, what it does is it provides us a runner. And so a runner is just a fancy term for a computer or a virtual machine. It doesn't really matter, what is the underlying infrastructure. They give you a little machine that we can provide a bunch of commands for it to run. Right? So just like in our terminal where we run commands like pytest or pip install, right? We provide these commands to a computer. And these commands are usually configured or provided in a YAML or JSON file, or even through a GUI, depending on what your CI/CD tool is. But the different commands that we provide that little mini computer to run make up all of the actions that our pipeline will perform. And this pipeline or this virtual machine that we have is going to run based off of some event getting triggered. And so, like I mentioned, this is usually us either doing a git push or performing like a a merge request. It doesn't really matter. There's a lot of different events that you can configure depending on your CI/CD tool. You can also set it up to run every single night at 2 in the morning. There's a lot of different options, but mostly it's going to be based off of a git push. And I wanted to provide just a quick example config of what our CI CD pipeline is going to look like when we're done. So this is just a little snapshot of it. It's not all of it, but I wanted to show you just how simple setting up a CI CD pipeline is. So this is the YAML file that we use to kind of tell the machine what are the steps that we want it to perform. And so you can see here, we've got this section called steps. So already you could tell we're just providing it a list of steps. Now, the syntax may be a little foreign, but you'll see that it's pretty easy to learn. You'll see that the first step that we have is there's this thing called action/checkout. So what this is actually doing is it's telling our machine to pull our code. So after we do a git push, it's going to pull our brand new code so that we can actually do something with the code. And then the next step is here we're setting up Python 3.9. So all it's doing is it's installing Python 3.9 for us. And then afterwards we have to update pip. So it's going to run python-m pip install --upgrade pip. So that's going to upgrade pip so we have the latest version. Then we're going to install the dependency. So that's pip install -r requirements.txt. So you can see all the things that we do on our local machine, we're just telling this little machine to do the same thing. And then afterwards, we then run pytest. So that's going to first install pytest. And then we just run pytest, right? Just like we did on our local machine, we're just telling the machine to do the same exact thing. So we're just telling the machine a list of instructions that we have done by ourselves manually. We're just giving that list to it so it can run automatically. Right? And so hopefully you guys see just how simple a CI/CD pipeline is. There's nothing magical to it. It's just like telling a machine, this is what we want to do. I want you to run this every single time we do a git push. All right. So hopefully you guys understand this. In the next video, we'll get started on setting up GitHub Actions so that we can actually build out our CI/CD pipeline. All right. Before we get started with working with GitHub Actions, I want you to open up a couple of web pages. So if you go to the GitHub Actions documents page, I definitely recommend you pull this up. Take a look at the quick start page and the reference page just to get an idea of how to work with GitHub Actions. I will cover everything, but you are going to forget some things I cover. So definitely know where the documentation is. Pull up the GitHub Marketplace as well. So this is where we can look up built-in actions that we can use in our CI/CD pipeline that have kind of handled a lot of the more complex logic. And then on top of that, you'll see that GitHub has this example tutorial on how to set up a CI/CD pipeline for a Python application. So this is what I kind of looked at to get started with building out a CI/CD pipeline for our Fast API. And it kind of covers most of the things we do that we need. So if you want to, you could just follow this. And I think at that point, you'll have a good idea as to how to work with this. But once again, like I said, we're going to cover everything from scratch. But if we go to the documentation, you go to Quick Start right here, right, it tells you that we want to create a folder called GitHub. And then in that folder, we want to create a folder called Workflows. So let's go ahead and do that. So in our main project directory, let me just minimize everything. I'm going to create a brand new folder. And I'll call this .github. And then we want a new folder within here called Workflows. All right, and so here we can define all of our workflows, which kind of make up our CI/CD pipeline. You can have more than one. You don't need to just have one in this case, but we're just going to use one because we're keeping things simple. And so here, this is where we're going to create a YAML file. So if you aren't familiar with a YAML, it's just a certain type of markup language that's commonly used for like config files and things like that because it's very easy to read. But the most important thing to keep in mind is that spacing matters in YAML. So you definitely want to make sure that all the things are lined up very carefully, just like it was when it comes to like the Docker Compose file. So we'll go here and I'm going to create a brand new file and I'm going to call this build-deploy.yaml. All right, and so we're going to give this workflow a name. So even though we gave it the file a name, we actually have to provide a name here. So we just do name and feel free to call it whatever you want. I'm just going to call this build and deploy code. Okay, and then we have to define when should our workflow, or in this case, which is our CI/CD pipeline, when should it run? When should it trigger? What triggers our code to run? And so like I mentioned, it's usually either a pull request or a git push. So to specify when we trigger this, you pass in the on field, and then you specify, should this be a push or a pull request, or should it run for both? And so if you want this to run only on get pushes, you would just do on push. If you wanted to run on pull request, you would do pull request here. But if you wanted to run for both get push and pull request, then you would do push and pull request. And there's a lot of flexibility too. So the way we have it set up right here, this would happen on every push on every single branch and every pull request on every single branch. But there's a possibility that maybe you don't want this to run for all of your branches, right? Maybe you only want this to run on the main branch and a couple of other branches, and then the rest of the branches you don't really care about. So what you can do is we can go down a level and then hit tab in this case. And remember, like I said, spacing matters. So we'll say push. And then here you can define all of the branches that should run whenever you do a push. So if I pass in main, what's going to happen is that this workflow is going to trigger every time we do a push, specifically only to the main branch and no other branches. And so you can provide a list of all the branches. So this is, another branch. This is, maybe some feature branch. All the names of the branches that you want your workflow to run on, you can specify that. And this is one way of providing a list in YAML. The other way is to actually go down here and then do a dash and then provide the name. So I would do main and then, some other branch and so on. And then if we wanted to, we could also customize all of the branches that should trigger this workflow on a pull request as well. So if I do pull request, and then I do branches, and this should be moved back here. And then here I do branches. And then I can do a list here as well. And I'll just call this, we'll give an example branch. I'll say test branch. Right. And so just to kind of read this through, anytime we do a push to either one of these branches, it's going to run our code. And anytime we do a pull request to this specific branch, it's going to run our code as well. So that's just how to set this up. We're not going to do any of that because we just have one branch in this case. So I'm just going to say we're going to run this on push and pull requests for all branches. And if we actually go to the documentation, I think, the reference page, you can go to the reference page and then select events that trigger workflows. And that's going to cover everything that we just covered. So it's going to go over all of that. And you'll even see that there's a scheduled event. So you can tell it to run kind of like a cron job, like, hey, I want this to run every single hour. And there's a few other like manual events that you can trigger and a couple of like webhook integrations as well. But we're not going to do any of that. We're just going to keep things simple for now. All right. So once we've defined what's going to trigger our workflow, we have to then create a job. And so if you go to the documentation, the GitHub Actions documentation says that a job is just a set of steps that execute on the same runner. So our runner is just a virtual machine. So when our workflow runs, right, we have to provide it a job, which is just a list of steps that's going to run on that specific runner in that case. And so here I'll go to jobs. This is where we provide a list of jobs. We're going to start out with just one in this case, and we can give this whatever name we want. I'm going to call this job one. Not a very good name. We're going to rename it in the future, but I want to just keep it simple for now. And what we want to do is we want to specify what type of machine do we want to run this on. And so like I said, a CI/CD tool like GitHub Actions is going to provide us a machine, a computer. And we have to specify what operating system do we want to run it on. So we're going to just use it on Linux, but keep in mind, you can run this on Windows, you can run this on Mac, you can even run it on all three if you want to test all of them. But since our since our production environment is running on a Linux machine, I think it makes sense that we do all of the testing and all of this on a Linux machine. So you pass in the runs on field, and then here we say Ubuntu latest. So this is going to be the latest Ubuntu version. And if we go to the reference page here and go to the workflow syntax, I think, and we go to jobs, that's going to provide us all of the information when it comes to what we can run this on. So you can see here, we can provide Windows 2022, or you can just grab Windows latest. We've also got, and I realize the text is probably small for you guys. We got different versions of Windows. We've got Ubuntu latest, which in this case at the moment is just going to be the same thing as writing Ubuntu 20.0.4. but you can grab any one of these specific Ubuntu versions as well as Mac OS 11 and some of the other previous Mac versions. But like I said, we're going to stick to just running on Ubuntu, and we might as well just grab the latest version. And so once we specify the operating system, the next thing that we have to do is provide a list of steps. So we kind of went over what the steps would look like when we did the little PowerPoint demonstration. So here we say steps, and then we provide a list of steps. So when it comes to lists in YAML, you just do the dash, and then you provide the lists. And usually when it comes to a specific step, we give it the specific command that we want to run, as well as a name, right? A human readable name, so that when we look through the logs, we know which step is doing what. So we can say like, hey, this step is installing Python, or this step is running PyTest. And so here, if we say name, this is where we provide a description for what we're about to do. So the first thing that we always want to do is we want to check out our code. And so I'm going to say, hey, this is checking, or I'll just say this is pulling Git repo, right? It's going to pull our code, and then we have to provide the uses. So this is the actual command that needs to run on our machine to pull our repo. And with GitHub Actions, like I said, there's a marketplace of pre-built actions that we can use to, essentially perform various tasks. So pulling your code is a very common task. So they've definitely got an action for this. And so if I just search for checkout, because I know that's what it's called, you can see this is the one we want. And so this is what's going to be responsible for pulling your code. And so here you just say uses, you do actions/checkout v2. And you could specify a specific repository that you want to pull. However, GitHub already knows what repository we're working on because we did a git push. And since all of this is integrated together, we don't actually have to pass in any other field. However, if you look at the documentation, you can specify what specific repository you want, as well as any SSH keys that you may need and things like that. But this is GitHub Actions, so it's all already hosted on GitHub. So it's a pretty simplified process. So all we have to do is just copy this right here. And we can just kind of continue down and just provide as many extra steps as we want. I'm just going to provide a very simple step after this just to show you, a step is just nothing more than us giving a command. So I'm going to name this one, say hi to Sanjeev. And what we can do is this is a special action that we grab from the marketplace. But if you just want to run a command on the machine, which is just a Linux machine, we can run any specific Linux command that we want because we have access to the CLI. All we have to do is just use the run keyword, and then we specify the command we want. So if you wanted to install a package, we could do, sudo apt install whatever. Or if you want to reload the machine, you could do a reboot. I'm not sure why you would do that. So all I'm just going to do is I'm going to just make it say echo, which is just going to echo out exactly what I type in here. I'm going to say, hello, Sanjeev. And so it's just going to run this command on our Linux machine. And so this is a very simple example so far, but I think that's a good starting point so that we can actually understand what's happening. And what we want to do is we now want to actually push this changes to our Git repository. So let me open up my terminal. Make sure you do save all. And so once we push this will actually be part of our repository, and it's going to actually trigger GitHub Actions to actually trigger this workflow because we said that on every push, we should run this workflow. So I'll do git add all. I'll do a git push. Sorry, git commit -m, adding first GitHub action. And then we'll do a git push. And we can do an origin main if you want to be specific. All right, so it's been pushed. And so now if we go to our GitHub repository, there's a actions tab right here. And so you'll see that I had a couple of other actions that ran because I was doing a dry run. But you'll see that the most recent one, which is the one we had, which is called adding first GitHub action. So this actually comes from the commit name. And we could select this and we can see exactly what happened. So this gives us a little summary. We can see that we have one job called job 1. And then we can see that the job ran and it successfully ran and it took 4 seconds. And if you click on the job, you'll see all of the steps. So the first thing is it sets up the job. And so you can see that it's creating a runner, which is once again just a virtual machine. And then it's going to provide us Ubuntu because we specified that as our operating system. It's going to set up a virtual environment. Don't worry too much about that. It's going to handle all of the GitHub permissions because it's all integrated with GitHub. Then we go down to the first action, which was pulling the Git repo, because we did say action/checkout v2. So then it's going to pull the GitHub repo. And then we could see the second option. The second action, which was say hi to Sanjeev. So all it's doing is just running this command on our Linux machine. So it's just saying echo hello Sanjeev, and then it just prints out hello Sanjeev. So this is all a CI/CD pipeline is. It's just providing a bunch of instructions for a little machine on the internet to run for us. Now, technically, the machine doesn't have to be on the internet. It doesn't have to be hosted. There's some CI/CD tools that you host yourselves on your own machine or your own server, so that they actually handle running all of this. Because even though GitHub Actions is free, they only give you a certain number of build minutes for free, and then after that, they'll start charging for it. So depending on how many times you build, it may actually be more cost effective to just set it up yourself. And then it looks like, GitHub Actions, there's a post pulling Git repo. So it's going to perform a few other like cleanup actions, and then it's going to then clean up the job. So we have successfully created our first simple example CI/CD pipeline, or GitHub Actions workflow in this case. So let's take our GitHub Actions to the next step. And I'm going to actually remove this example. I just wanted to show you guys how to do that. But after we pull our GitHub repo, the next thing that I want to do is I want to set up Python. And so to set up Python, once again, we can go back to the marketplace, if I can find it, because setting up Python seems like a very common task. So we can just search for Python. And keep in mind, when it comes to setting up Python, you could technically just do the same thing where we can say uses, and then we can run the command on a Linux machine to install Python, which would be something like sudo apt install Python, right? We could 100% do that, and that would 100% work. But because this is such a common task, there's already a pre-built action, so we don't even have to do that. And I think I searched for Python. Did that work? It didn't look like it worked. Here we go. Set up Python down here. So this is going to be responsible for setting up and installing Python on our machine. And you'll see an example of how to do this. You just say uses action/setup Python at v2, and then you say with, and then you specify the version, and then you can also provide the architecture as well. And what's really cool about this is that, let's say we wanted to test our code on multiple different versions of Python. Well, we can go under the strategy section. So right under where it says runs on, we can do strategy, and then we can provide a matrix and then a list of versions. So if we wanted to test version 3.7, version 3.8, 3.9, 3.6, and make sure that our code works on all of them, we can then create this matrix here. And then when we go to set up our Python, right, we would say with, and then for Python version, instead of providing one specific version, we actually pass, this is essentially a variable syntax in YAML, and then we just call matrix.python version, which is referencing this list right here. And so it'll just run our actions for all of these versions just to verify that everything works in all of the versions. But we're going to keep it simple. We're just going to do version 3.9. If you want to play around with it, I definitely recommend you try testing this out. But for us, it doesn't really matter. But keep in mind, it looks like you can even do the same thing for different operating systems. So if you want to test on Ubuntu, Mac, and Windows, you can do the same thing as well. But like I said, we're going to keep things very simple. And I'm actually going to change this to name, give this a name. I'm going to say install Python version 3.9. And then we'll say uses, and then we'll call that action now. So we'll do action/setup-python at v2. And then we pass in with tab, and we'll say python-version. And we'll say 3.9. And I think that's all we have to do. Let me see the example. Python version 3.9. Yep, that's all. We can leave the architecture. I'm going to use the default, which looks like it defaults to x64, so not a problem in our case. All right, and then after installing Python, the next thing that I want to do is I want to upgrade pip. So I'll create a description of update pip. And then we'll say uses. Actually, instead of uses, we're just going to run a command on the Linux shell. So we'll say run. And we just run python-m pip install dash dash upgrade pip. So this is the command that you would run on any Linux operating system or even on a Windows machine to upgrade pip. And then the next thing that I want to do is we're going to install all of our dependencies. So since we pulled our Git repo, right, with the actions checkout, we're going to have access to all of this code and we're going to have access to our requirements.txt. So we have to make sure that we install all of these packages there as well. And so here I'll just say this is install all dependencies. And the command that we're going to run for this is going to be and you guys should know this is just pip install -r requirements.txt. All right, so I think this is a good starting point. Let's try committing our code again. So I'll just do git add --all. We'll do a git commit -m, added more steps. And then we'll do a git push origin main. All right, and then we'll go back to actions. Right, and we can see that our workflow is starting to run. That's why it's yellow. And we can take a look at its current status. So it's still running job 1, which is the name we gave it. And we can just kind of follow along. So it looks like it pulled our repo, installed Python version 3.9. It's then updated pip, and that's already completed. And now it's installing all the dependencies. So obviously installing all the dependencies takes a certain amount of time. That's probably going to be the longest specific step in our GitHub workflow at this point. All right, and it looks like that ran, and then it's essentially cleaning things up, and then it's completed, and we get the beautiful green check mark. So we can just close out of this, go back. And you can even see the list of all of our workflows that GitHub Actions is detected. So we have built-in deploy code, so that's the only workflow that we have, but keep in mind I can create essentially as many different YAML files inside this workflow folders to have different workflows. So I might have one specific set of, I might have a workflow specifically for one branch and a completely separate workflow for another branch. It just gives you a lot of customizability, but we're just going to have one workflow that works across all of our branches. Now, the next thing that I want to do is I want to run PyTest. So to run PyTest, right, it's a pretty simple process. So let me set up the name first. I will say, test with PyTest. And then we'll say run. All right, and I need to run 2 commands. So if you ever want to provide a list of commands to run, instead of having to create multiple different steps, I can do a pipe, go down a line, and just provide the list of commands. So we'll do pip install PyTest, and then we can go down a line and provide the second command. So then we just run PyTest. And you can, pass in whatever flags if you want the -v and the -s. But I'm going to keep it simple, and we're just going to keep it blank for now. Let's save this, and I'm going to then do the same thing. We'll do a git add --all. We'll do a git commit -m. And I'll say added PyTest step. And then we'll do a git push origin main again. And so from a learning perspective, right, this is kind of a slow process because we have to push all of our changes, and then now we have to wait for this whole thing to run. But once you understand how all of this works and how easy it is to set up, you won't have to keep doing this every single time or every single project. You can just essentially copy and paste most of your workflow. All right, so it looks like it's completed, and we get a red X. So it looks like something broke, and that's to be expected. And it's going to highlight what specific test failed, or sorry, what specific step failed. But we can see that it was the running PyTest. So if I just open this up a bit and then expand it, we can take a look at what the error was. So it looks like it installed PyTest, and that seems to have worked fine. And then down here, you can see that there's a couple of validation errors. And so it says that, we didn't provide a database, hostname, port. So it looks like there's the issues with environment variables. And that makes sense because this is a brand new computer that we haven't touched. So none of the environment variables have been set up. So obviously it has no environment variables, and our Pydantic validation of environment variables should have failed, and it did absolutely fail. So this is all to be expected. And so in the next video, we'll figure out how we can set environment variables in our workflows so that we can provide the information for reaching our specific database. So there's a couple of different ways that we can set up environment variables, and there's a couple of different places where we can define them. So I'm going to show you how to set a job specific environment variable. That means this is an environment variable that will only be accessible from within one job. So in this case, our job that we've been working on is called job one. And so if you want to set an environment variable, you just set it right here. So we say env, and then you provide all of your environment variables. So in this case, let's say we want database hostname. And in this case, it's going to be localhost. We've now successfully set up one environment variable, and I'm just going to copy and paste all the others. And so now we've defined all of our environment variables in this case. And that should fix the issue. But I want to show you guys what other environment variables that we have as well. And if you want to know where I'm kind of getting all this information, like I said, we have the documentation, and there should be a section for environment variables here. And so I think we should see the same thing, right? Yep, we see the same thing. So env under the specific job, and you just provide the list of all of your environment variables. And then there's some built-in ones. So these are default environment variables that get set for you. So here you can see what's the run number, what's the GitHub job, what's the action path. We can even see what's a repository. So if you want to get the name of your repository, you can reference this specific environment variable, but we don't need to do any of that. But what I do want to show you is, if I had gone in and then created a second job called job 2, right? This environment variable that we defined here is not available because this is defined under job 1. So if you want to have an environment variable that's shared across all of your jobs, I can specify an environment variable here. So I can say env, and then I just provide my environment variable. So I could just copy this one as an example, and we can provide this. So then database hostname is going to be available for job 1 and job 2. But for now, we're just going to remove that because we don't really need it. We don't really need that right now. And I'm going to keep everything as default in this case. And we're going to check this into Git. So I'm going to do a git add -- all. We'll do a git commit -m, added env variables. And we'll do a git push origin main. Okay, and then back to our actions page. If I see the added environment variable section, we can see that failed. Once again, this is going to be expected. So if we go under, it looks like there's a weird failure. No steps defined. Okay, so we got an error because I accidentally left job 2, so it doesn't like the fact that I have jobs 2 with no steps. So we're going to save this again, and we're going to do another commit. And I'll just call this committing again because I'm getting lazy. Right, and let's just make sure that we've kicked this off. All right, so it looks like we kicked it off, and there's no major show-stopping errors at the beginning. But we should still see this fail, and that's to be expected. But I just want to make sure that we no longer have issues with environment variables. And I want to make sure that the environment variables that we set did successfully get applied to our runner. Okay, guys, so a couple of things to point out. So there's a whole bunch of errors, and that's to be expected, and that's okay. But we can see that it did process all of our environment variables, so that's great. So we did fix that issue. But you'll notice that when we're running our test, we get a whole bunch of errors, and then eventually you'll see a whole bunch of SQL alchemy errors. And the reason we see a whole bunch of SQL alchemy errors is because if you look at the environment variables, we're pointing to localhost for our database. There's no database on this runner. This is a brand new computer. Why would there be a database installed? So we do eventually have to set up a database for testing on the runner itself, or we would have to point it to a remote database, whether that's hosted on Heroku or AWS, it doesn't matter. But for testing purposes in your CI/CD pipeline, I'd rather create one on our runner that we can just quickly spin up for testing. So once again, I just wanted to point out how to set up environment variables. The one thing I don't like, and I want to make sure I want to teach you guys, is that in this case, we're hard coding these values in here. And so this is all stored in our repository. Anyone can have access to it. This is our test database, so it's not a big deal. But I do want to show you how we can store these as secrets so that the runner has access to them, but no one else can see them, because storing it in here could potentially cause issues. If you didn't want this, the password and the username for your test database to get out. In my case, I don't really care, but it is important for you guys to understand how to actually do that. So as I mentioned in the last video, our environment variables are hard coded into our workflow. So technically when we check this into Git, anyone can see it, which may or may not be a problem. But if it is a problem, I'm going to show you guys how we can work with GitHub secrets. So if we go to our GitHub page and go to settings, here there's a section called secrets. So we can define secrets that we can use and access in our workflows. And so this is a repository secret. That means it's globally accessible across the entire repository, across all branches. There's no, any kind of environments or anything like that. So we'll select new repository secret. And here we just give it a name. So if you take a look at our environment variables, I figured since that's what it's going to represent, we might as well use the same one. So I'll say database host name in this case, and then just give it a value. So localhost. That's it, right? It's just a key value pair. We do add secret, and then you'll see it's stored in here. And so now in our code, if we want to reference the this secret, which I happen to call database hostname, we just copy the name of the secret. And then what we do is we use $ curly brace, so 2 sets of curly braces, and we say secrets dot and then the name of the secret. So this will allow the runner to access the secret from our GitHub repo so that our workflow code doesn't actually expose all of this information. And so this is what you want to do for your passwords and things like that, especially when it comes to storing the information for connecting to your production database, which we will do in one of the later lessons. But before we proceed any further, I want to actually show you another option. So I'm actually going to remove this repository secret in this case, which is once again a global secret that our entire repo can access. Instead, what I like to do is I like to set up environments. So you can set up a whole bunch of secrets that are available depending on what the environment is. So I can create one for testing, one for development, one for production. It gives us a lot of flexibility. So I'm going to create a new environment, and I'm going to call this testing. And within the environment, we're under the testing environment, we can add a secret here. And so we're going to do the same thing. I'm going to call it database hostname. And in this case, we'll say localhost. We'll add the secret. And we can provide as many secrets as we want. And then what we can do is in our job, we can specify what the environment is for the job. So I can say environment. And then we provide the name, which is going to be testing, right? This is going to match up with whatever name we gave here. So I called it testing. So we give this the name testing, and it's going to have access to all of the environment variables that we defined here. And the way to access them is exactly the same way. You just do $, 2 curly braces, secrets, and then the name of the environment variable. Now, if there's an overlap with the name of your environment variables when it comes to the ones that you set in your environment, as well as the one you set globally for the repository, I don't actually know who takes precedence. I suspect it's probably the environment, but you should check the documentation to verify. But we don't have any global secrets. I'm going to be using environments for everything. So this keeps things nice and simple. And so now that we've set up this one, let's go ahead and just set up all of these while we have the option. And so we're going to set the port as well. Here we'll set the password. We've got the database name, which we'll just say fast API. Then the database username, it autofills because I ran through this all in a quick trial run before I started recording, so it's kind of cached in there. All right, and so now that we have all of our environment variables or our environment secrets set, we could just change all of these to reference those secrets. So we just do the same process, and in this case, it's just going to be the same exact name as the key in this case. All right. And so now that we got all of these set, let's just save this, and I'm going to check this into Git now, just to make sure that everything is kind of working so far. And we'll take a look at the job real quick, and hopefully there's no errors or only errors that we expect to see. And what did I call this one? ASDF. Oh, okay. So it looks like it failed already. So we clearly did something wrong. This workflow is not valid. Unrecognized name database underscore port. Well, what happened there? And it even tells me the position. So if I select show more, database underscore password. So let's see. What did we mess up? Yeah, simple mistake. I forgot the secrets dot before all of my variables. So that's why it had no idea what that was. We have to reference secrets to actually get access to them. And now let's try this one more time. All right, this looks a little better. All right, and so now if we look at the test with PyTest, you can see that the environment variables were passed in, and GitHub will automatically kind of hide what all of the secrets are, because once again they're secrets, so you shouldn't see them. But it does show that we were successfully able to retrieve them, and we got the same error down here. This is just an issue with accessing the database because there is no database on localhost. So it's trying to connect to a database that doesn't exist, which is going to create all sorts of issues. So in the next video, we'll figure out what we can do to set up a test database on our runner so that we can actually run our tests. So when it comes to setting up a database on our runner, the easiest way to do that is to create a service container. So what's going to happen is GitHub Actions is actually going to allow us to spin up a Docker container, which really is the easiest way to set up to set up Postgres on a remote machine. That way we don't have to worry about any issues with potential installation of a Postgres database. And so I recommend you take a look at this tutorial, which kind of walks you through how to set up a Postgres service container. And it just gives you an example in this case, which we are essentially just going to copy in this case. But here we just, under jobs, we specify a service. We give this service a specific name or label, and then we just tell the image that we want to use. And in this case, we're just using the default Postgres image. This is the one that comes from Docker Hub, by the way. But you could technically use any image that you wanted to, but it's Postgres, so we might as well just use the default one. And then we can pass environment variables into the Docker container as well. So one of the things that we want to do is set up the password for Postgres, as well as even potentially the database name. And then what we want to do is we want to set up some health checks to wait until Postgres has started, because until Postgres starts, we should not run any tests because the tests are going to fail because the database is down. So we want to make sure that Postgres is up and ready before we actually start running our tests. So we're essentially just going to copy this line here. But let's go back to our code and we'll take a look at how to do this step by step. And so I'll just go under the environment variable section here, and we'll create a section called services. And I'm going to create a service called Postgres. And we're going to provide the image just like we saw in that example, and that's going to be Postgres. And let's pass some environment variables. So the first thing is going to be the Postgres password. So we're going to do Postgres underscore password. And here for the password, we can literally reference the same exact secret because they're going to be using the same password. And then we also want to give it a custom database name. So we want to automatically create the fast API underscore test database so that we don't have to do it in code. So I'll do Postgres underscore DB. And we'll do $, and then here I can pass in, where's my database name? So this is just going to be fast API at this point, but we want fast API underscore test because that's what our code has been set up to run. So we'll do underscore test, right? So this is kind of like string interpolation. So same thing. And then at that point, I think our Docker container is pretty much set up. We do have to specify the ports that we want to open up. So we'll say ports. And we want to do 5432. and then 5432. So this is what we want. And you're probably thinking, well, can we use the variables here? And I tried to do this. I tried to paste this here and then paste this here. And I actually got errors. I don't know why it didn't work, but for some reason this wasn't allowed. So you have to hard code these values, unfortunately. And then lastly, let's set up the options. So I'm going to just copy these options right here because we want those health checks for sure. Let's save this and make sure that all the spacing lines up because a lot of times the spacings can mess up things. I have a auto formatter, so with for YAML syntax, it'll automatically format it so that all the spacing is set up properly. You want to make sure that you do it manually or set up or install a extension in VS Code if that's an option for you. Okay, so we've got our Postgres database, and I think we should be good to go. So let's try this: git add all, git commit. All right. And so we can see that our most recent test in this case happened to succeed. And if you actually go to the test with PyTest and just see the results, we could see that 46 tests pass with no issues. And so that means it did successfully connect to our database. And after that, it essentially completed the job. So now we've successfully added a database and we've successfully set up our CI pipeline. This is the CI portion of things to pull our code, install Python, set up, install all the dependencies, and to run our tests. So all of this happens in an automated fashion now just by doing a git push. So you could see how easy it is to get things started. And so I think from the CI perspective, the last thing I want to show you guys is how to essentially create a Docker image in our runner and push that out to Docker Hub so that our production network can then pull that brand new image.